gentlemen, and cyborgs. How's everyone doing today? Welcome to the one and only Voidstar Lab, where I just realized that the print that I have had going for the last day ran out of filament somewhere around a couple hours ago. How's everyone doing today? How are you doing? How are you doing? I hope you're all right. You in the back, I see you there. How's it going? Welcome to the lab. I realize that a lot of folks are talking about the music, and I realize that it's because I usually forget to enable it during the spinning cube of title card. Yes, welcome to the Hack with Me stream. It's a bit of an experiment. Usually I try very hard. Hang on a second. Before things get too far out of hand, here, allow me to turn your attention over here. You can see that I've got my desk is of course very well organized as usual. But check this out. This is something I haven't been able to do before. How intriguing. Yes. How intriguing. I can now move the overhead camera to look in the 3D printer closet, and unfortunately it still doesn't let me look into it. What I was trying to show you, and what I'm struggling to, is the printer on the left has run out of filament hours ago after printing the next iteration of this, of my last client project, and it failed. So, A, crap. B, let's switch back over to our monitor. And let's go ahead and cancel that. It's on the Anycubic Viper, and I've got that. Oh, this is way behind. Like, Edge does this weird thing where it will buffer. Basically, if a web page isn't active, it'll buffer the incoming data or something, so that when you switch back to the tab, it runs through it at fast forward. It's really weird. Pardon the nugs, I'll explain in a second. Wolf220 says, was there not a filament sensor? There is a filament sensor, but the Viper is not configured to pause the print when the filament sensor goes off. And I know there's a way to handle this in G-code, and that is one of the things that we could end up doing today, is tweaking the tweaking the start G-code in Prusa Slicer to enable filament sensor filament runout pausing to happen. Right now, it doesn't do anything when the sensor trips. It beeps a few times. It pops up a little box on the touchscreen, but that's it. Anyways, let's cancel this before. Oh, it almost made it too. Damn. All right. Yeah. Anyways, as I was showing you before, let's. As I was showing you before, it doesn't seem like I can ever go two episodes without changing around my camera setup. But trust me, it's good. I've got this. I've made a few minor improvements here that I think should. Well, they're minor from your. They're minor from your point of view. They're major on my end, even though it's kind of hard to see over there. For one, I now have the overhead camera is now separate from the lamp, so there should be and it's on a much sturdier mount, so there should be less jiggling, right? Like now, if I even whack the table, sure it'll wiggle a little bit, but that's it. Before it would wobble forever until I grab the camera. The second thing is, oh, for crying out loud. What's going on here? Did I forget to plug it back? I forgot to plug it back in, didn't I? Yep, I forgot to plug it back in. I switched things around so that the 4K camera, so the Blackmagic, is mounted on an adjustable mount, and it'll be easier to use. There we go. And this should also wobble less. I'm gonna give it a whack. Yep, you see now it is much more stable, and I can still move it around a little bit so we can focus on different things. So yeah, Voidstar Lab is being improved bit by bit. Oh, talk about burying the lead. I didn't set up the hotkeys for this. Crap. Well, first off, it's at an angle. Aw. There we go. Must have sagged a little bit. I mounted a camera on. Oh, it's still at an angle. I mounted a camera on the Ultimate Printer, which has been renamed from Squirt-Cephany to Squirt-Boris because it has multiple heads, right? Multiple extruders, get it? Anyways, yeah, now we'll be able to keep an eye on the print as it goes. Yeah. So let's see what else. Yes, Sequoia points out that my voice no longer gets further away when I walk away because I finally invested in a wireless headset. Did that last week. Anyways, this boat right here is made of PPS. It's made of, I forget what PPS. It's made of polyphenylene sulfide, which is, according to the manufacturer, is widely used in the most demanding applications because it has excellent chemical resistance coupled with superior mechanical and thermal properties. In particular, the bullet point here that I want to draw your attention to, and this is on 3DX Tech's website. This is manufactured by 3DX Tech. This is the line I want to draw your attention to. Excellent chemical resistant, insoluble in any known solvent under 200 Celsius. So you could put this thing into 200 degrees Celsius, cyclohexanol, isopropyl alcohol, boiling water, and probably even like exotic, probably even resists like some acids. I imagine you could dunk this thing in fuming nitric acid, and this Benchy would be a-okay. So yeah, it would deform a little bit, right? Because the heat deflection, the glass transition temperature is 85, but you could dump this thing in 190 degree. I don't even think you could even bring something like cyclohexanol to 190 degrees, or just start evaporating. Anyways, that's a lot. Yeah. Yes, respectful drip master. You're gonna taste the wrath of either our bot or our mod. Please refrain from spamming. Anyways, yeah, so one of the things we're going to do today is print boats for the upcoming Every Filament episode. We still have plenty to do. In particular, we still have, I believe, 2 or 3 high-temperature filaments. Yeah, we've got, we still have PPSU, and we have PEC that we need to print in high temperature. And we also have some multi-material. I haven't done any support filament just yet. So, yeah, that's some stuff we have to do. I just realized that I hooked up another camera. For crying out loud! I hooked up another camera in the 3D printer closet, but in my infinite wisdom, I didn't get the hotkey working. I got halfway through setting up everything in OBS. I'm basically hang on, let me get this thing in a less ridiculous position. There we go. So, yeah, we adopted a dog a week or so ago. Yeah, a week. So we got a dog about a week or so ago. His name's Peter, and we recently adopted Peter's brother. We got him on Saturday, and Peter's brother is a nervous wreck who is barking at literally everything, and he's been barking. He's been going absolutely mental. He's been going absolutely mental on every couple hours, and oh man, he's yeah. Anyways, like I haven't got any sleep, so I'm like running on like 2 hours of sleep right now. I barely had any time to prepare. So yeah, don't worry, we're still gonna get a lot of stuff done today. I'm just explaining why I'm eating chicken nuggets. B, why I look like death itself, and C, why I haven't talked about things.com. Yes, today's episode is sponsored by Things, your place to get all kinds of 3D printable files, both to host them and to download them. Now that we have, we actually rated them. We actually rated Things a few days ago when we did our resin episode. Yeah, we hooked up this Halot Sky 3D printer, and we ran off all kinds of stuff. And yeah, I ran off. Here we go. We've got a My Little Pony that I got from Things. We've got oh, where's the keycap? The keycap is the important one. Where did I put it? Well, we print. Oh, here it is. We printed a Shrek keycap. Let's switch over here. Boom. Yep. We got all this creepy crap from things.com. Use the link in the description. Check it out. The site is super easy to use, loads super fast, has tons of files, including mine. I put nearly everything I make for this channel and pretty much everything I show off for this channel up on things.com. Go ahead and check that out. Use the link in the description. And thanks a lot. Akalia, thank you so much for the extremely, extremely generous super chat. Doggo Toy Fund for good but nervous doggos. Aw, yeah, they're having a little trouble sharing. I think. But thank you very much. We definitely have a trip to Petco planned. We got to figure out some way to make Edmund the new doggo feel more at home, so that I can get some sleep. Seriously, the guy won't shut up. Anyways, yeah, today we just have some assortment. Pardon, we have some assortment. That's right. We have an assortment of projects to work on. We have some. We want to print some boats. We still have plenty of filaments to try out. We also have some various lab upgrades to do, such as I just realized getting my hotkeys set up so I can show you the other printer. Yeah, we've got the last client project. In that it's an interactive, not interactive, I guess. Basically, it's an art piece. That uses a motor to drive a huge disc of like a huge art piece in a disc. It's like a mandala, and yeah, basically the circuit is very simple. It's my favorite. It's the TNC, of course, combined with a TNC, of course, combined with a motor driver, and that is connected to a stepper motor and a USB battery pack. And that just gives it a little turn very subtly. It's supposed to subtly turn it over time. So as people explore the gallery, they come back, they pass a piece, they go, ah, that's neat. They come back later, and they're like, wait a second, wasn't this different? And, yeah, it's pretty cool. Anyways, all the parts are now in. We got remember the circuit boards that we ordered in a past episode? Well, they're in. We've got all the parts, I think. And I haven't yet tested them. The idea was to reprint the this thing, the enclosure frame thing, and I got halfway through it. Hopefully we got far enough that we can at least check the dimensions. Unfortunately, we're not going to be able to finish that one today. This means because it takes 15 hours to print. So maybe we can start the next one. But at the very least, I want to get the circuit done so we can test it. Oh, I should probably update you on the filament dryer, the air fryer filament dryer. So a few streams ago, I turned an air fryer into a filament dryer, and it exploded. Well, some folks were pointing out in chat that it could have been the circuit could have been mains referenced, and it turned out to be correct. What ended up happening is that the power. Remember when I looked up the power supply chip? Oh, I never turned. Hang on a second. I never turned my shelves on. As is tradition, 'twas written in the stars that at the beginning of each stream, Zack will remember that he has to turn on his shelf and draw attention to his patrons. Anyways, yeah, so it's not isolated. That means that the digital ground is the neutral line on the outlet. And it's not isolated, but the PC sure is, and the USB power bank sure is. And when we connected them together, we connected the digital ground from, USB and stuff, to the return on the to the return on the whatchamacallits. Rudy Nemo, to the return on the mains. It's just what a pain in the butt. Anyways, it exploded, and I realized that it didn't make sense to repair it. Because, it's too dangerous to have... Basically, before, it wasn't so... The way the manufacturer designed it, it wasn't much of a risk. Because remember, there's no electronic part that the user can touch. All the controls are capacitive touch sensing, and they're behind the panels. There's nothing you can touch. Meanwhile, I'm over there putting like a knife switch and buttons. Basically, it meant that like if I was playing with this thing and there was like a surge, I could get blasted. And it was just too unsafe, so I decided to scrap the entire project. And I ended up hunting around for a convection toaster oven that had a feature that let it stay on forever, which is about as good as we can do. Rudy, thank you so much for the two. Oh, we got 2 super chats. 20 towards the lapel mic. Aw, and the rest of the 20. Hate to see the road go awry. Why is there a problem with the audio? I gave it a test, and I thought it sounded good. If there's what's going on here? Is there a problem with the audio, or it doesn't look like we're clipping? Let me maybe I move it a little further away from my face. Maybe I was eating the mic. Hang on one sec. I'm just gonna go into my. I want everyone to have an excellent audio visual experience. So I'm just gonna let's see. Definitely we want this guy here. I'm just going to go into my sound settings. I'm going to loop it back. There we go. Yeah, I'm going to loop it back onto my headphones so I can get a sense of what it sounds like. I can see if there's anything funny going on, because I gave it a test, but it seems like a lot of folks are hating the audio to the extent of giving me money to change it. So let me see. Let's see how this is going. Listen. Mic check. Testing. How are we doing here? Ladies, gentlemen, cyborgs. Ladies, gentlemen, cyborgs. How are we doing today? This sounds fine. This sounds alright to me. Today we are hacking all the things. Literally every electronic part on planet Earth we are going to hack. CIA hacked, NSA hacked, your Game Boy hacked, your Xbox hacked, your mom's PC, your dad's PC. Yeah, everything sounds fine. Well, let's see if it's still a problem. Bear with me 1 second. I'm just gonna go into. Yeah, we don't even have a compressor or anything going. Maybe that's the problem. All right, let's add in the compressor. Yeah. All right, I think that should make it work a little better. Yeah, how are we doing here? Is the audio sounding all right? I didn't need to compress the audio before because I didn't compress the audio before because I was moving all around the studio, and that was causing the levels to go nuts. Yeah, if it's still a problem, I can switch back to. If it's Dominic Dern says this sounds fine personally. Let's see. Rudy says the setup does not contain reverb, so your audio isn't in sync with the room you're in. Let's see. I'm just going back and reading some chats. What does yeah, I do have the lapel mic. I just didn't want to futz with I just don't have the adapter. This is a Shure system, and it's got that really weird mic connector with like the 3 triangle prongs with the one in the center. I don't know why it needs 4 prongs for one mic. Anyways, it seems to be working all right. Dominic, thank you so much for the super chat. I really appreciate it. Yeah. Anyways, let's get some stuff done. No, I take the audio really seriously because I try to make all of my stuff, both episodes and streams, possible for people to listen to. Because, I like making listening to YouTube as I hack, and I assume that other people do the same. Hence today's episode and all my attendees. Let's see a little. Get this guy out of here. Get this guy out of here. Sorry for the fuzz. I mean, this sounds excellent, but it sounds too clean and not like you're in your lab, but in a studio. Oh, I gotcha. There's no room character. I see. Well, yeah. I guess I don't know why it usually comes up more with the. I'm still getting all the audio dialed in. I really appreciate all the super chats. I'll take all this into consideration. I think we need to get building. We need to get making some stuff. So let's let's see. First, I'm gonna switch you first. All right. Let's see. Pardon. We're gonna pop up the. Pardon me one sec. We're going to switch you over to a black screen. We're going to start in the third bullet point here. We're going to do some lab upgrades to facilitate the rest. I realized that I should have done this ahead of time, and I totally had sex with the dog here. So, yeah, we're going to see. We're going to add the aux. Let's see. What are we going to do here? The Sultan nameplate and the Sultan stream have to go into their own group. What I'm doing right now is I'm just rigging it up so again I can use my little keypad here to show you what's going on the printers. Because if we're going to do some printing, I want to show everyone the printer. So let's see. This only take a few seconds here. I can't remember how to add a group. There we go. All right. All right, so we want this and this here. I know this is really unprofessional. I know I should have done this ahead of time. Oh man, to be totally honest with you, like I know this is like breaking operational security here. I know it's kind of breaking the fourth wall. Why did that just happen? Oh my god. But like. Got a few too many projects going, like a few too many projects and videos going on, and just there's between the dogs and there's just so much stuff piled on. I think I'm just gonna have to switch this by man, I didn't want to do this. Let's see. Is this gonna work? No. Ah, crap. Anyways, you can see up in the corner. Oh man, looks like it's too big. You can see up in the corner that we got printer vision again. Yeah, that's right. I finally fixed the bandwidth problems, and I did it really easily. I just bought a really long USB extension cable. I know, right? I just got a really long USB extension. Why isn't the green rim showing? What's going? Oh, what? Oh, crap in a hat. Yeah. So I finally got. So like, I just bought a really big USB. I just bought a really long USB cable, and yeah. Why can't I? Oh, this is. Hang on a second. Oh, for crying out loud. There we go. Ah, there we go. Excellent. All right. Martin Bach says, "Give me your best hacker voice. I'm in." Keep on being awesome. I really appreciate it. I'm in. Hang on. I have to do some hacker typing. All right, I think that should be fine for now. Unfortunately, we're just gonna have to switch manually back here because I don't have the hotkeys set up, and I don't want to make everyone wait. So if we're gonna hack, I have to switch over to I have to open up my hacking program. Hang on. Let's go over here to our hacking program. Let's hack the planet. I need more time. The firewall is. They got too many firewalls. It's too fiery. Almost there. Almost there. Uploading the. Writing the GUI in BASIC. Establishing uplink. Having trouble getting through their satellites. And we're in. I'm invincible. That's a bit of a deep cut. Right. Let's build some stuff. Oh yeah, the Ultra Black says, I wonder if the code actually does something. Yes, the code on Hacker Typer is pulled from. I think it's pulled from GitHub. I think it's pulled from GitHub repos. I think they just randomly pick a GitHub repo with the given text and start typing it out. I'm pretty sure if it's JavaScript, it's coming directly off of npm. And if it's Python, they're just Python libraries. But I think for other languages, it just searches like GitHub. At one point, it was really funny. At one point, Hacker Typer. So what Hacker Typer does, it makes it look like you're typing code. Basically, no matter what you type, it types code. At one point, it would print its own source code. That's what Hacker Typer that's what the hacking was. It was printing its own source code. So that was pretty funny. Anyways, let's rock and roll. Let's build some stuff. Yes, that's right. OBS hand jobs for the homeless says OBS being a bee. That's right, it does that. At least it's not as bad as Streamlabs OBS. I have been screwed in so many different ways by Streamlabs OBS. Well, without further ado, let's make some stuff. First things to do are let's extricate our print from here, figure out what our next plan is for this printer. Then we're gonna go over to the Sultan of Squirt, and I think we'll print Reflectolay. I'll show you what that is in a sec. But first, let's pry this guy off and see if it's good enough for the media. Let's see. Oh, I can actually see what's going on. This is so good. Oh, it popped off on its own. Excellent. So this is made of PPS, which is a high temperature filament. This one isn't as. Let's see. This is a high temperature filament. It's not as high temperature as stuff like Peak, right? Because it prints at a mere 330 Celsius, not 230 Celsius, 330 Celsius. It prints at a mere 330 Celsius, and it's not quite as strong. But what it gives you is chemical resistance. We talked about this briefly at the beginning of the stream, but yeah. Yeah, look at that. So you can see with there's always going to be sagging, and there's always going to be sagging and a little bit of blobbing with this filament. Sagging because there's no cooling fan. The chamber reaches about 60 Celsius during printing. It should actually be hotter. I just don't have a heater. Yeah, it reaches about 60 Celsius during heating, so there's no way to cool it. And it's going to ooze a little because all these filaments take on water like a sponge, and even though I've been dehydrating them for days, they're still going to take on water as the print goes. Yeah. Although, like, you notice that what's weird about all these high temperature filaments is that the overhangs are really good. They're actually really good at bridging, and yeah, it's because it's really weird because usually high temperature filaments sag a lot, like nylon, polycarbonate. They sag a lot, but this stuff is really viscous these tend to be very viscous as they come out of the nozzle, and they tend to set up quickly on their own. One other thing that I didn't realize is that all high temperature filaments have to be annealed. That's part of why the boat that we printed before, the Peak boat, was so weak, is because all these filaments, they don't get their full strength until they're annealed, because the filament actually crystallizes. It's part of what gives the high-end filaments like Peak and PSU and whatnot their strength, is that they actually they crystallize, and some of them even crystallize into glass-like structures, which isn't really crystallization. I don't know how it works. Anyways, yeah. So this one looks good. This it's not the nicest Benchy, but if you were planning on making something that had if you were planning on making, I don't know, like if I was desoldering chips, or if I was like decapping chips, right, and I wanted to make like some tongs to lower the chip into nitric acid, because that would attack metal tools, then this would be perfect. I think it resists acid. It says no known solvent. I don't know if an acid counts as a solvent. Anyways, I think that looks alright. So let's yeah. It looks pretty good. So here, take a look at it while I preheat the printer so that we can run off a different high temperature material. I'm gonna have to vacate the premises for a couple of minutes because I got to go. I kept losing. All right. So what I've done right here, by the way, is let's grab this here. So what I've done here is set the bed to 150 Celsius and set the tool to 370. Pardon me, because we only have two materials. We only have two high temperature plastics left. We have PPSU and we have PEC, and I think PPSU is the one to try to do. I think it took a lot of damage. That's a lot of damage. Yeah, some of these filaments were just between, like, they've just been through a little too much trauma, and a couple of them have become brittle in the during the drying process. So we got PPSU, which is like practically spaghetti. That stuff's gonna crumble. We're gonna have to keep an eye on that and constantly and make sure we keep feeding plastic in. The last one is PEC, and PEC I really wanted to save for the stream because it's widely known as the easiest high temperature filament to print. It's it's extremely high performance. It's an extremely high performance polymer, just barely worse than Peak, but still far stronger. Like it's flame resistant. When it burns, it doesn't smoke. It resists chemicals. It resists radiation. It's also extremely strong. Glass transition temperature 162 Celsius, high above the boiling point of water, and great thermal properties, but it's very easy to print. From what I've heard, it's not much more difficult to print than PLA, assuming your printer can handle it. So yeah, we're gonna give this a shot. This is it's pretty exciting. Yeah, looks like people are still arguing about the quality of my sound. If there's anything specific for me to take a look at, feel free to let me know. I do take this really seriously. Anyways, I'm gonna move this nozzle over. Let's see. I don't have to control. I just realized I don't have to control. I control this from my computer. I don't have to actually like poke the screen. Herpity derpity. Yeah. So I'm going to just move this guy into view, and then I'm gonna go grab some high temperature filament, and we'll do a little high temperature printing. Let's center this. There we go. Beautiful. Wonderful. So people are pointing out that I have a lot of tabs. Yes, I have been saving the tab. Like as I print materials, I've been keeping the tabs open so that I have an easy reference when I write the episode afterwards. I want to do the printing before I write the episode because I don't want to say, oh, this is super easy to print, it looks great, when in reality it's actually a giant pain in the butt. Yeah. So bear with me one sec. We're doing let's see. Bear with me one sec. We're doing a little I gotta grab the thing. Gotta grab the stuff. Brooke is saying that I am so bad at chat. Let's see. It does look like now that I turned on the compressor, looks like our audio levels are a bit lower. So yep, this should do it. I don't want to blow anyone's eardrums out though. So I want to be a little on the conservative side. Brooke says, I love you. Look, there's only I only got two eyes, and I'm unfortunately stuck pointing them in the same direction. So, yeah. Let me just make sure I haven't missed any super chats here. Did I? Sam Blind Maker, thank you so much for the super chat. My audio is perfect, dude, no matter my visual. Yeah, I'm inclined to trust someone who calls himself a blind maker when it comes to audio quality. Thank you very much for the super chat. I really appreciate it. Bear with me one sec. I'm just going to go into the other room, and I almost ran in there without grabbing myself some forceps. I do not want to grab some filament out of a 100-degree toaster oven with my bare hands. So stand by one sec. I'm just going to go and grab this. I don't think the mic is going to last. I don't think the range is going to be high enough. Well, I don't know. Who can tell? Oh, we got some doggos. Got some doggos. What's Edmund doing in Peter's crate? He's just hanging out there. Let's see. Oh, okay. Looks like I made a boo-boo at some point. Huh. This must be the peck. You don't want to touch this, doggo. Oh, watch out, pups. This is hot. You're gonna get hurt. I'm getting followed by dogs. I'm being chased by dogs. Ah! Here we go. All right, looks like I was wrong about the PPSU. I think I already printed it and just forgot about it. This, oh, it's hot. Oh, it's really hot. Is the peck. Oh no, that's not the view I want. I want this one. Ah, that's hot. It's so hot. Ah. Yeah, so this is peck. You'll notice that it's a much lighter. Oh, you could hear me through the entire trip. Oh, awesome, excellent, cool. Very nice. Yeah, this thing is like designed for like concerts and stuff. It's a little over specified, but you know, I like buying equipment that I never have to replace. Anyways, ow, jeez. Yeah, so this is the PEC. You'll notice that it has first off, it's transparent. PEC and PEEK are basically made of the same building blocks, right? PEEK is polyether ether ketone. It's a polymer made of those monomers. You know, I think in that order. I'm not 100% sure. This is PEC, polyether ketone ketone, and basically, even though they're sort of made of similar stuff, the different monomers give them different properties. This one is clear, and I believe that if I'm not mistaken, I think PEEK starts out opaque and it prints clear. And I think this is clear and prints opaque. I'm not 100% on that. But because it's full of ketone, it's going to smell a little bit as it prints. Not dangerously. None of these high temperature filaments. One of the things that makes a filament high temperature is that it doesn't degrade when it gets hot. So these things are actually very safe in terms of fumes. It's, in fact, when it comes to, in fact, when it comes to these high temperature filaments, the filament itself is actually very, very safe. Even more so than regular, because they resist abrasion too, so there's no microplastics. So they're actually very safe filaments. It's the printer that's dangerous because it's so hot. Speaking of, this guy is now a cool 370 Celsius. So I'm going to move our camera over here so you can watch as. Let's see. Still getting a little used to this. There we go. So you can watch as I pull out the filament. We're gonna pull the filament out, and then we're gonna bundle it up from the spool, and we're gonna spool this up because I only have one high temperature spool, as you will see. All right, let's get in there. Let's get in there. All right. So we've got our Titan Aqua extruder selected. We've preheated it to 370 degrees. I am going to pull out the feed tube a little, and first I'm going to try to manually release it. All right, good. Yeah, because I want to relieve all the tension. I want to avoid any liquid plastic getting stuck in the. I want to avoid any liquid plastic getting stuck in the drive gears. Because basically we'll have to strip the entire thing down and use a blowtorch to get it off. So, okay, awesome. Looks like we're done here. All right. You'll notice that I'm not using. So remember, if you remember a few streams ago, we tried to figure out what purge filament to use for this. Like how to clear it out. Like, basically a low temperature filament to use in between something high temperature like PEEK or PEC and like something like nylon or polycarbonate. It turns out there aren't any. It turns out that the actual way that professionals purge the high temperature filament out of these things is you just run purge filament through and smoke pours out of the extruder, and you just run cleaning filament through and it burns it, and them's the breaks. That's just how it works. So that's what I did. But we're going to avoid doing that unless we have to. Because, it does involve burning plastic. Simple Sample says, "Are you a real person?" Allegedly. I mean, people sure think I am. All right, so let's swivel this back over. Isn't that a great word? Swivel. It's one of those words like beverage that no humans use in real conversation. It's just for corporate robots. Oh, it looks like we're a little saggy. So if you're wondering what I have this thing mounted on, it's sort of this multi-armed tripod. It's multi-armed stand thing for streamers. It's supposed to have like a thing for the mic, a thing for a ring light, a thing for a camera, and instead I have it set up with, right now I have it set up with 2 cameras and the light, but there's a place for a third. I have a place to mount my phone if I ever feel like it. At some point, I'm going to get an Android phone, whose sole job is to be my mobile camera for streaming. We're perfecting the stream setup here. Oh, let's get my cough drops out of here. I blew my voice out yelling at a dog. They were being very bad boys. Oh, we got to glue this guy together. So yeah, this is high temperature spool. It's made of steel and brass standoffs, and we have to use this because the temperature in the chamber can actually get hot enough to start deforming and melting a plastic spool. Plastic spools are usually made of generally ABS. ABS, usually polycarbonate or ABS or something, and they start melting at a pretty low, like a surprisingly low temperature. Oh, I can't take this off yet. I have to bundle it up first. Let's grab myself some zip ties, some zipties. There we go. So I'm just gonna thread the ziptie through the holes, like through the witness holes. I guess that's what that's what they are. Through the witness holes in the spool, and just gonna bundle up the filament so we don't get any tangles after I take it off. Because this filament's ridiculously expensive, and I really want to be able to salvage as much of it as I can. Because holy crap, is this filament expensive! All these low temperature ones are, or all these high temp filaments. Speaking of, I have low temperature filaments on the brain because I actually I printed this. See, I printed a boat in this polymer called non-oilin, made by, I think, Filamentum. Anyways, this material non-oilin is called that because it is not made with any petrochemical products at all. It's pH, I think it's PLA and PHB mix, which I've never heard of before. It's PLA and PHB, and it prints at a really low temperature, like only like 160, 170 Celsius or something. Lowest printing temperature regular filament that I've ever seen, and it made the nicest Benchy of them all. Of all the filaments we've tried in all the episodes, this non-oilin stuff was definitely the nicest Benchy. So yeah, that's why it's on my mind. Low temperature. Yeah, it's neat trying out all these different materials. There's all kinds of cool properties, all kinds of neat stuff. The first, yeah, as you'll see, the theme of the first one was PLA, because pretty much every commercial off the shelf, pretty much every mainstream commercial filament is PLA. The theme for this one is going to be nylon, because there are a ton of different things you can do with nylon. You name me like pretty much any substance, and I can find you a nylon with some of that mixed in. There's not, yeah, man, there's glass nylon, there's carbon fiber nylon. I've seen, like, there's nylon mixed with TPE, because nylon wasn't flexible enough already, I guess. Here we go. Check that out. Nice and easy, spooled up. Oh man, there's so many nylon mixes, so many polyamides. I didn't even know that there were multiple types of nylon in the first place. When people talk about nylon or polyamide, they're usually talking about one of two plastics, PA12 or PA6, and they have significantly different properties, which I thought was pretty intriguing. I never realized that. So this is already spooled up, but I've had a lot of tangles with these spools before, so we're just gonna reassemble the reel. And we're just going to spool this up by hand, because this filament should be more or less unbreakable. We don't have to, yeah, this filament's super tough. So we don't have to worry about it breaking. So it's actually very easy to spool back up, as long as it doesn't spring open when we take it off the reel. Yes. There we go. Very nice. What the Flux says, carbon nanotubes. Yeah, I actually have, I think I tested I think there are 3 filaments here that have carbon nanotubes. I believe it's 3 of them. 2 of them advertised that they had graphene, or are they graphene or carbon nanotubes? Are they the same? I don't think so. Right? I keep forgetting. Is graphene the ones that are like little little balls, little Buckminster Fuller geodesic domes. Or is graphene the ones that sheets, or does it also account for the tubes? I need to look this up. Anyways, yeah, there are a few of them that have carbon nanostructures, and they're almost always in there for ESD, basically for allowing the filament to discharge static. So you can make stuff like test jigs and whatnot, which really would have come in handy, because I've printed a lot of test jigs, and I know that they've destroyed at least a couple products because of static buildup. So that would have been good to know. That all I needed were carbon nanotubes or sheets or something. Carbon and nano. We need both. That's kind of what we're getting at. All right, now let's hope this doesn't like completely snarl. All right. Looks like it's being well behaved. So yeah, E3D sent me the spool. This isn't one of their products. This is actually something they developed to use in-house. Because yeah, E3D themselves, they're the folks who gave me the printer. They're sponsoring that episode. Speaking of, I'll talk about things at some point. But yeah, anyways, they supply they supply a lot of nozzles and a lot of hot ends and stuff. And a big part of that is making sure they work with all kinds of filaments. So they've got this filament library of hundreds of polymers. And they use them to to do test batteries and to run, basically to try out their products. I really wish I had like a turntable or something, like a Lazy Susan that I could put the filament on, because as you rewind filament, it twists it, and eventually those twists can make their way down the line and mess up the rest of the spool, and it's just that's how you get tangles. All right, come on. It's part of the fun. Don't worry, it's only take a few seconds. If I was, you can tell I'm confident that I'll be able to do this quickly because I left the printer idling at 370 Celsius. Anyways, they have tons of filaments in the library, and they sent me some samples, including this one. And they also sent this metal spool, because you need everything involved when you're doing high temperature work. Everything has to be high temperature. Everything, even the person doing the testing has to be hot. Let's see. Again, like, I'm not going to spend too long on this. If we're still unwinding filament, if we're still winding up filament in 5 minutes, I'll just cut the filament there, because we're only printing one Benchy. I think they sent me 200 grams, but we only need about 50 for I think 50 for a Benchy, 30 somewhere in the neighborhood. The tangling's inevitable. The tangling's kind of inevitable. We know it's not in it shouldn't be in a knot. We haven't given it any opportunity to knot up, so we should be able to detangle it just by pulling the loops away from each other. There we go. I'm being aggressive with this because, again, this filament's basically indestructible. But if you're ever respooling, you want to be very careful to constantly twist to constantly turn the reel over as you wrap, because that will keep the filament from tangling, or at least reduce the tangling. Let's see. It's not a problem. Sean Cook says, "Lol, how not to do it." So, let's see. Oh, I'm twisting it in the opposite direction. Let's see. So, Sil Timmer asks, what kind of filament is this? This is PEC filament, polyether ketone. It's a high-temperature engineering filament used to make things that have to be autoclaved, things that work with, things that have explosive in and around them. Just any place you need a ridiculously strong 3D print that resists everything. Chemicals, impact, radiation. Oh, it did break. Huh. There we go. Oh, I didn't. Yeah, the peak never even came close to breaking. Oh, well, that's kind of disappointing. We'll keep an eye on it. We'll make sure it doesn't. Well, keep an eye on it. I, I wish the tool changer had run out sensors. It sadly does not. So we'll just keep an eye on it. Let's see. This is about half a Benchy's worth of filament that's already spooled up. So let's just try to. I'm just gonna put another couple minutes in here to. There we go. Put another couple minutes in here to see how much of the rest we can wrap up. All right. Yeah, the filaments. These high temperature filaments are pretty rad. Yeah, the high temperature filaments are pretty sick. I can show you the couple of ones that finished printing properly. I had a lot of trouble with the carbon fiber peak, and I'm downplaying that a little. What I mean to say is that carbon fiber peak was the hardest filament I have ever printed. Every way a filament could be a total friggin' nightmare, that filament was a total nightmare. Like, it blew my mind. I didn't know a filament could be that hard. It was as brittle as spaghetti. It jammed constantly. Oh man, it had to be printed at a ridiculous temperature. And as the print was finishing, I read on the manufacturer's website that if you allow it to fully cool down while it's still in the nozzle, it will permanently clog the nozzle, like forever style. So yeah, that was that was a fun moment. That didn't panic me at all. All right. Let's see. Give this thing a little twist. Yeah, unfortunately this high temperature spool isn't we can't adjust the diameter of it. Which is why I couldn't just take the sample bit, the sample reel, and just whack it right on, because the inner diameter here is much smaller. This isn't really intended to hold samples of filament. This reel is intended to hold like a master spool, like it's supposed to be a master spool, so it holds like an entire 2-kilo roll of filament. So we're not exactly playing to our equipment's strength here. Let's see. Let's just wind this up a little bit. I do like how slick the filament is. It's very satisfying to handle. So let's give this a little wind. Let's see. Oh, it fell on the floor. Oh well. Let's see here. Yeah. So this is PEC filament. Let's just give this a little twist. What's a twist? There we go. Get this unwound, and we'll get this all set up, and we'll load it in, and we'll print ourselves a high temperature boat. Yeah. The other reason why I wanted to print this is because some of the other high temperature filaments, like this last one here, PPS, prints at crazy low speeds. Like, I think they recommended I print this at 16 millimeters per second. That's less than a quarter of what I usually print. At. Less than a quarter? No, it's about a third to a quarter. Yeah. Depending on what the nozzle diameter is. So, yeah, this stuff should print much faster. It should print closer to 40 millimeters a second, I think. Like, unless it's much different. Yeah, I've got to get all this dealt with so then we can do peak. Remember, we actually tried to print peak on stream a few weeks ago, and it was just far too waterlogged. It was a total disaster. Oh man, that boat, it crumbled apart in our hands. Somehow it finished, which was really weird. I didn't see that coming. I even set we even set a poll. We even polled the audience to see how people thought it would fail. And to my surprise, it didn't. It actually worked. But it ended up being so brittle it just crumbled apart in my hands. So yeah, that has to be thoroughly dehydrated. In order to do that, we got to put it on the metal spool. And in order to get the metal spool, basically, yeah, the metal spool's so big that it can't dry any other filaments in the dryer with it, so I have to finish all the other high temperature filaments first. There we go. We're coming to the end. Let's see. Is this the most efficient way to wrap filament? Probably not. Probably not. Believe it or not, I don't know how to do everything off the top of my head. Radovan Obal asks a really interesting question. I hope I pronounced your name right. Is PEC also biocompatible? I don't know. That's actually a really interesting question, because PEEK is commonly used for implants and for things that like interface directly with a human body, because the human body does not. PEEK is so I think it's just so unreactive that the body won't attack it. So you can make stuff like implants out of it, and your body won't reject it, unless I'm misunderstanding how all that works. It's pretty neat. Dan Wolf Chronome says, Zach, add another 50 Celsius and increase the speed. It's that usually works, right? Like in general, that's kind of the rule. But I don't think that plays as well with high temperature filaments. Because I don't think that works as well with high temperature filaments. Because what you're talking about is increasing it from 400 Celsius to 450 Celsius. So I don't know what will happen. I'm not sure what will happen. I will say that they specifically recommend that 3DX Tech specifically recommends against that on their website. So I guess we could try and find out. I'm imagining that some part of it will either overheat, or like the printer will fail to keep up, or it could be the material even burns. Like it could be that it just prints at a temperature very close to its pyrolysis temperature. So, but I don't know. On top of that, like we can always try like printing at a high speed and then just dropping this. Ooh. We could try printing at a high speed and then dropping the speed from the web interface. Could always give that a shot. But I think this should print about 30 millimeters a second, which gives us, I think, around a 3-hour Benchy, which is why I want to do this first, because I want to max out our chances of actually finishing this here. Yeah. So let's see. There we go. Easy peasy. All right. We had a break, but that's fine. Everything's fine. Everything's fine. It's fine. Everything's fine. Oh, I need to give myself a little more slack here. There we go. All right. Let's get that in here. And let's load her on up. I'm just going to go over to my other monitor here and confirm our temperature here. All right. We want to print 345 to 375. So I have this currently set to 370. So once we load the filament in, I'm going to drop the temperature down to 360 while we get ready for printing. So, all right, where's my? Here we go. I printed these detachable. Which is the side we're working with here? We're going to work with this side. Yeah, I printed these detachable filament holders because this printer's design makes it really hard. Let's see here. This printer's design makes it really hard to install the filament when the bed is at certain positions. So this should help alleviate that. We should be able to get it in through the side, just like so. I have to make sure not to touch the bed. You might ask, why did I preheat the bed so early? And that's because we're using it as sort of like a chamber heater. This the stuff needs to be printed at in a warm chamber. And I don't actually like. I have this reptile heating pad in here, but it only raises the temperature by a few degrees. And so we're using the bed to sort of raise the internal temperature. We also have this dehumidifier within the enclosure itself, which I've had running, which I leave running all the time, and that increases the amount of time that the filament can stay in the chamber till it starts to come apart. All right. So we got our PEC. So let's come on. It's not getting picked up by the teeth. Come on. What's going on here? going on? There we go. Nope, we missed. uh, it's hard to get this stuff to actually line up. I think it's just the nature of the Titan extruder. It's a bit of an open design. What's going on here? Let's see. Ground into it a little bit. All right, just pulling out. I'm manually relieving the tension to kind of get it in. I'm going to move this over a little bit so I can get a good look at the side. I think that should do it. Let's send that filament. Full send. All right, come on, come out the end. Come on. Is it going? Come on. Maybe it missed. No, it's getting pulled in. No, it just hasn't primed yet. Come on, filament, you can do it. There we go. Oh, I saw it move. There we go. Oh, we are officially squirting. Oh yeah, it's happening. Ah, there we go. Okay, so I can't use a paper towel to wipe off the nozzle as usual because this is 370 degrees and the paper towel burns at 200 something. So I think, anyways, yeah, I've got to use a brass brush, and I'm being very gentle because this is a nozzle X, and it's got. If I'm too rough, it will remove the coating and turn it from a nozzle X into a nozzle regular. And you know I like it extreme. All right. So we're primed and ready to go. Let's see. Yeah, we're primed and ready to rock. Unfortunately I moved the carriage as I moved the gantry as I was trying to fill it up. So we're gonna have to manually return the tool. So I'm just going to go into my files menu here. We're going to open up our macros. We're going to manually run the script to disengage the tool. There we go. We're going to have it return the tool, even though it's not carrying anything. It's going to miss. Yep. There we go. It missed. And now we will dock it by hand. All right. And I'm just going to change the standby temperature to 350, to 350. There we go. All right, so now everything's primed. Let's head back over here. Oh, well, that's a bit of a design flaw with this, isn't it? Oh man, the amount of stuff there is to do. It's too much. There's too much stuff on the Zack's plate. All right, let's take a look here. Let's see layer height, no special concerns. Heated chamber, 70 degrees. Right now it's 42, but that'll continue to rise as we print. I found this filament's pretty low warp even without the heated chamber. So I think these specs are a little too conservative because they expect you to be printing larger things. A Benchy is very small compared to what a lot of the prints they're demonstrating are. The question is, how fast can we print? Let's open up the technical data sheet. Let's see. So they're recommending layer height of 0.25 millimeters. That's a lot. They also use 100% infill, which I would imagine contributes to them wanting a heated chamber, because a lot more filament inside means more force warping it. But let's see. I'm not seeing any speed recommendations here. Yeah, I'm not seeing any sort of speed recommendations. So I'm guessing that it says substantially easier to 3D print than Peak. Well, I certainly hope so. So I'm guessing that we can run this stuff at almost full full power. I'm gonna double the speed. I think we'll try printing this at a max speed of. What do you think, 40 millimeters per second? Probably 30 or 40. Yeah, I think we'll do that. Joseph Lafayette says, Zack, are you secretly the Loch Ness Monster? I don't think so. I don't have much of an accent. I don't breathe very well underwater. Although I guess like there's no way I can prove that I'm not the Loch Ness monster. So there you go. Wolf220 says, "Is the tool changer run on Octoprint? I'm curious how you got the macros to work. It's running on it's the Duet what's it called, Duet Wi-Fi. Yeah, it's the what you saw was built into the board itself. It's the Duet web interface. And it's actually pretty rad. Uh, and Arcades Gershiak. I am messing that up like crazy. Let's do 35 millimeters per second. I'm inclined to agree. That's a pretty good conservative speed to run filaments at. Let's do that. Okay, so I already have the model open here in Super Slicer. One of the things we may do today is port everything over from Prusa Slicer to Super Slicer. So yeah, we've got this thing currently set to PSU. Let's see. Yeah, our material is PSU. Oh man, yeah, I can't increase the resolution on this because it doesn't work. They didn't implement it. They didn't implement it properly. So it looks like they want us to print this at about 360 degrees. Looks like our. Let's see. Let's open up our. Hang on a sec. Let's tab back here. Okay, so it looks like our bed temperature 120 to 140. So let's just try this dead in the middle, 130. There we go. And let's see, they want us to print 345 to 375, so 360 seems all right. Okay, very good. So this is our filament material here is PEC. The reason we pick it from this dropdown is because it will, it should change the name of the file, I think. Yeah, all right, so cooling, it doesn't matter because it has no part cooling fan. Yeah, and our print settings are really conservative, like really. So let's change these. So perimeter speed, let's try. So we're gonna do max of 35, right? So perimeter speed will do 25. The external perimeter is half that. That's all right. Infill speed 35. Supports 35. Although this doesn't have supports, so it doesn't really matter. Solid infill, I'm gonna do 35 there as well. Top infill, we're gonna up that from 15 to 20. Let's call it 20. Bridge speed of 35. Yep, faster bridges. Stretch it out a little bit. Thin extrusions, we'll leave that at 10 millimeters a second. And thin walls, let's keep that at 30. Travel speed, we can really bring this up. Let's go to 200 millimeters a second because we're not worried about breaking this filament. This filament's pretty tough stuff. So first layer speed is, let's see, right now it's at 10 millimeters per second. Let's call it 20% for perimeters, or 20 millimeters for perimeters and 25 for infill. No, I meant 10 millimeters. All right, there you go. So that's what it should. That's what it should do. Max print speed. Oh, I never even tried this. When setting other speed settings to 0, Super Slicer auto calculates the optimal speed to maintain constant extruder pressure. Huh. I don't want to try. I'm not sure I want to try this with material that's like $800 a kilo, but we definitely want to try that at some point. See. I do like it when a computer sets parameters for us. We're gonna up our layer size to 0.2 millimeters, and we got our brim enabled. Let's see, slicing it up. It's estimating 1 hour and 37 minutes, which seems plausible. This is printing on a 0.6 millimeter nozzle, so that seems plausible. Cool. All right. I think that seems reasonable. Let's see. What am I forgetting here? Sam Settleoff says the only slicer that works with the tool changer. I'm not sure. Like, it seems like Prusa should work. It has multi-material settings, but I don't know. I think Hira can also do it, but this was the one I was strongly recommended to use Super Slicer. So I trust Renee when it comes to this stuff. He hasn't done me wrong in the past. All right, so we're using number 1. We're using our modified material, right? Yep, we're using our modified material. Let's send it. Check this out. I rigged it up. Nope, it didn't change the name. Let's see, PEC. I rigged it up so we can print directly from Super Slicer. Haha. Come on, you can do it. You can do it. There we go. Let's let's see. I'm going to quickly switch us over to... I'm going to quickly send everything to black. Don't worry, your stuff is fine. There we go. We're going to turn this off. We're going to turn this off. There we go. So now we have an inset view. There we go. Now we can keep an eye on this thing from multiple angles. Check this out. I can even... Oh, we ran out of wire. I was going to say I can even move this closer, but we ran out of wire. All right. I think that looks pretty neat. It's, you know, the whole thing's still a work in progress, but I think it's promising. Yeah, I realized that like the 3D printing is just such an important part of the show. I gotta have a setup to show off the 3D printers. Yeah. It's working pretty well. A little overexposed though. That's it's a little weird. I thought I turned on the the auto exposure. I guess auto exposure is not working. Come on. Oh, there we go. That looks kind of cool, doesn't it? All right, so it's picked up the tool. Now it's going to bring it up to temperature, and here we go. Now I'm going to just go check it out and make sure that it's baby stepped down correctly. If it doesn't stick, we'll add on more adhesive, but we should have plenty of adhesive left. It's not sticking. No good. Yeah, no good. It looked like we had plenty of adhesive left, but we didn't. All right, hang on one sec. This is only going to take a few seconds because we don't want the... We gotta hustle here because I don't want the temperature dropping too much. I just want to scrub away... Yep, there it is. Scrub the extra filament off. And let's get this out of here. Let's open this. I don't want to let too much heat out. We're just going to add on a fresh coat of nanopolymer adhesive. This is sort of like the equivalent of a glue stick for high temperature printing. And honestly, for anything, this has kind of become the nuclear option for like if a thing doesn't stick to the bed, just get some nanopolymer on it. I know it's what's his name? Joel, the 3D printing nerd, has also been using this stuff a lot, and it's really rad. So I'm going to put a nice thick layer, extra thick, and yeah, then I'm just going to... I'm not going to change anything else. It looked like the height was correct. I'm just going to restart the job. Let's go back to status, hit print again. There you go. It should go pretty quick because we haven't... Should go pretty quick because we haven't given it much of a chance to cool down. What I'm doing right here is just using some isopropyl to clean the adhesive off of the brush, so we get some extra life out of the brush. There we go. What's cool about this stuff is also you don't have to wait for the bed to cool down. You can just throw it right onto a red hot bed, and it works fine. That's cool stuff. All right, there we go. So that should work pretty well for us. Really nice. Thick benchies, indeed. Handjobs for the Homeless says, I don't see a fume hood, which I assume you want if you print those exotic materials. They don't really off-gas. One of the things that gives them their high temperature and one of the things that gives them their performance properties, both like the strength and the resistance to heat and chemicals, is that they're really hard to decompose, so they don't really off-gas that much. I believe, yeah, they don't really off-gas that much. And I believe the gas, like I checked this out. The gases they do emit are not dangerous. This one should emit a tiny bit of ketones and a tiny bit of a very small amount of ether. Basically, it'll smell, but it won't actually hurt anyone. The other material, PPSU, it releases, I think, ethylene gas as a byproduct. So things would get a little weird if I had plants in here. But for humans, it's totally safe. All right, sticking perfectly. I'm just going to watch the first two lines go down to make sure they're touching. Let's see. They're not. We're just going to baby step down a little bit. I think I'm under extruding on the first layer. I think I have something configured wrong. It doesn't justify. Let's see. It doesn't justify stopping the print and starting over. It's just something that we want to improve at some point. There we go. All right. Looking good. Huh. Pretty cool. All right. So let's unfortunately we're going to see 2 copies of it here, but that's all right for now. Yeah, my OBS is in shambles. I've just, oh man, between the dogs and other stuff happening, and keeping the workshop together, finishing the last client project, coordinating the videos for the next few months. It's been crazy. This is why I didn't want to make it full screen, because the printer camera is suction cupped to the side of the printer, so it's going to wobble a little bit as it prints. There's no real way to avoid it. So this shouldn't be a problem unless you're looking at it full screen. But I just wanted to give you a look at what this camera is showing. You can see the first layer going down pretty well. This material goes down clear, and then as it sets, it turns a deeper yellow. So it doesn't look like anything's happening, but it certainly is. Joel Driver asks, what are the temps? This is, let's see, this PEC is printing at 360 Celsius, and the plate is at 140, which makes this the 3rd highest temperature material that we printed for this episode. Number 1 was carbon fiber, I think, yeah, carbon fiber PEEK, which had to be printed at 400 Celsius with a 150-degree bed. It's hot stuff. Yeah, I like getting in there and seeing this angle. Aerator asks, what does the gas do to plants? Ethylene is a plant hormone that signals that that fruit should ripen. So if there were plants in here and they're exposed to a high amount of ethylene, it can make their fruit if they have fruit or seeds or stuff, it can start ripening prematurely. Let's see. Not Telling says, Houston, we have string on the nozzle. That is unavoidable. Remember that's unavoidable. Yeah, all we can do is lightly try to knock it off with a brass brush, which we can't like really aggressively scrub it because that would strip the coating off the nozzle, and we can't wipe it with anything because any sort of rag or paper towel would be burned, and that would leave even more residue. Ian Ross says, where can I get exotic filament samples? That is a great question. You can get exotic filament samples. Let's see. Matter Hackers has. Well, it depends what country you're in. First off, if for me to get all the filament samples for the upcoming Every Filament episode, I had to go basically everywhere, right? Like pretty much every place that sold filaments. I got some from Global Filament Sample Depot. I got some stuff from Matter Hackers, Printed Solid, 3D. Yeah, whatchamacallit? globalfsd.com, Global Filament Sample Depot, and Matter Hackers are the 2 with the largest selection, but no one's selection is comprehensive. There are always going to be some filaments you're going to have to get from directly from the manufacturers. It's pretty neat. Not Telling says Rockwool would probably work for a wiper. That's interesting. I didn't think of that. Rockwool is like how would I describe it? It's like fiberglass made of gypsum. I guess that's how I would describe it because that's exactly what it is. Yeah, it's fiberglass made of gypsum, and it's often used as a growing medium for plants. And I didn't think of that. That might work. I think maybe like ceramic. I think like ceramic felt or ceramic sponge could also work. I would imagine that's probably what they use. Rainbow Orange says insulation. Have to be careful because gotta be careful because fiberglass could strip the coating off the nozzle. Dan Wolf Chronom says, thanks a lot for the super chat. How's about making a nozzle cam with a USB endoscope? It's mesmerizing. Would be great for the streams. I'm thinking about it. It's not appropriate for this printer because the high temperatures of the nozzle would, I think the high temperatures in the chamber could be a problem. It's also, there's a limit to how much wiring I can run through it. But maybe on one of the other printers, that could be interesting. I did a little looking around and I didn't see any that had a video quality that I would feel comfortable, putting on my streams. Let's get this Let's get this mat out of here. It's not heat proof. But yeah, it's something to think about. I think maybe one day I'll take like all of the community suggestions and put them into one printer, like a put them into one printer, like a Voron with what was like a Voron with the mosquito nozzle running clipper with a USB endoscope on it. That would be pretty funny. Tim Bellum says I installed Rockwool insulation in my workshop. It's excellent sound. It's excellent acoustic treatment. At the old workshop in the back room of the Fat Cat Fab Lab. That's how I prevent it from echoing so much, is by putting up just big sheets of rock wool with felt over them. Don't have to do that now. Yeah, don't have to do that right now. Yeah, let's open up. All right, let's move on to. Let's see. So next thing we could. So let's see. Next thing we could do is get another filament going in the other printer. But you know what? Let's do some electronics for now. The whole idea here is to mix things up. So yeah, I kind of expected that most people who are listening to this are going to be working on their own project, because you know, I acknowledge this isn't the most scintillating of topics, you know, but not the most exciting of topics. But you know, projects still have to get done. So if you're working on something interesting, feel free to leave a chat and let us know what is cooking, because I'm just as curious about what you folks are working on as I would assume you folks are about what I'm working on. Weirdly shaped packages are one of the many joys of building electronics. Let's see, what did they send me as an entire tube? Oh, headers. Yep. Did I just get one? These are no way. These aren't like one really long header. Did I mess this up? Did I get like multiple rows here? 40 position, 2.5. Did I get the wrong headers? I guess I got the wrong headers. I don't know how this happened. I was super careful. Oh, nope, never mind. They just packed them. Never mind. I thought I bought 2 row headers by accident, but I did not. These are single row headers. They just packed them 2 to a tube. So these are 40 positions long. Yep, there we go. Okay, so I thought these were like, I bought, instead of buying like a bunch of small ones, I bought one really long one. Instead of getting single stack, I got double stack. But it looks like they just packed them up 2 to a tube. So that's great. Yeah, these are the low profile Swiss headers. And I do actually have, I bought some of these. I do already have a bunch, but I made a mistake a while ago of buying 2 different varieties. So I have some sockets that don't match some pins, and I got some pins that don't match some sockets. So I decided to just pretend I didn't have any and just buy a fresh batch, because it is slightly wasteful, but so is yeah, like it is a little bit on the wasteful side, but then again, so is, you know, having mismatched stuff that we can't use together. I realize the color temperature on my webcam is way off. I just cannot win today, can I? All right. So yeah, we've got connectors here. We're going to need a whole bunch of these headers. Yeah, we're going to need a whole bunch of these headers because the Teensy and the motor driver module from Palalu both need them. We have some spring connectors. Some spring terminals. These aren't actually the full spring terminals. We're going to reuse some stuff I already have. Got some fresh chip quick. Remember running out in a past episode? Let's see what we got here. We got our USB-C. I hope those fit. We got some 5.1K resistors to signal through USB-C that the thing wants a full amp. And I think that's it. We already have a lot of the other stuff like the Teensies. So yeah, one of the big question marks here is if the USB-C port is going to, basically like if these USB-C connectors, let's focus please, are going to fit the footprint, because I implemented the footprint from the manufacturer's recommendations, but as I've made very clear, everything always goes wrong. So let's find out. Let's put this to the test. We're gonna move this off to the side here because we're gonna need some tweezers. Let's see. The weird color. The weird color temperature is making my nails look weird. Let's get that out of there. Beautiful. All right. Moment of truth. Oh, let's try to actually position this in a way you can see. Oh. This is the hardest part. Hardest part, assembling stuff without blocking the camera. I think that looks pretty good. Is this as far as we can zoom? It sure is. I think this looks alright, except, yep, our circuit board is too thick. Our circuit board is too thick. The pins are not protruding through to the other side. We're going to be counting on solder being wicked. Yeah, let's check that out. We're counting on solder being wicked inside, which means that I'm going to have to flux these up before we solder them, even though it's it's through hole. So it looks like this is not really through hole, it's just hole. They are making it through, but barely. But it looks like the footprint is sound. All the pins are making it through, which is good. Excellent. Cool. So yeah, let's build some of these. Let's build at least one of them. Before we get too distracted, I'm gonna flip on my soldering iron, and I can oh yes, I can actually turn on my fume extractor because it shouldn't get picked up by this mic. So now I can actually turn on my fume sucker. Let me see if I can get it in view. Nope, I can't pull it out of there. Well, this is so good. All right, let's grab some of these guys. Let's see. Hopefully we can repair this. This is the USB hub that probably didn't, but might have gotten destroyed when I blew up the Instant Pot. Yeah, good stuff. Good. It just ain't Voidstar Lab unless stuff's friggin' exploding. Oh, it looks like the boat's coming together. You can see you can see that's printing opaque-ish. Probably means that there's a little more water in it than I would like, but what can you do? Brendan Hull says I'm assembling a 668 thanks to one of your videos. Sure. Oh man, that's great. It's cool. It's a cool keyboard. It's definitely one of, if not the best, 60% fully 3D printed. There are plenty of other open source mechanical keyboards, but that is one of the few that is fully 3D printable. All right, so we've got this spring connector here. I need this to be 4 units long, or 4 positions long, but it's only 2, and that's because I already have a bunch of these left over from past client projects, and the reason I bought a 2 instead of just breaking these up is because they have an end cap piece right here, and I bought these in. These are 20 position, so they only have 1 end cap. I would need so that's why I bought the 2, because I need more end caps. So let's put these together. I'm gonna try to split these open without the little tabs flying off into oblivion. Let's see, these go like so. Oh, that sucks. These have the these ones here have the. Let me switch. Oh well, all right. Well, looks like we're screwed. See, this is what I was talking about. So these have the pins going like diagonally staggered. So that's what I assumed. That's how I assumed this would work. So yep, you see pins or the pads are diagonally staggered, except these are in a row. So it looks like we're gonna have to split these up as well. We're gonna have to split these guys up. Yeah, I have to split these up, and it still doesn't help us because the end cap piece. The end cap piece is in the wrong position. Man, DigiKeys. Yeah, check this out. Not even this part fits. DigiKeys datasheet that it linked was wrong. All right. well, this sucks. We're gonna have to use the ones I already have, and we're gonna waste one on the end, because without the end cap here. Ow! I stabbed myself. All right, 1, 2, 3, 4. Let's see. So I'm just using this. That's what this little notch here is for. You get something in there, and you can split them apart. So we're gonna lose the one on the end, because without the side plate, yeah, the little tab is gonna fall out. But this is what we have to do. Oh well. Yeah, I tried. Look, this is the nature of the game. You can never expect your design. Here we go. Now this just slots into place. You can never expect your design is going to work perfectly the first time. So this board is actually a combination of surface mount and through hole. We have a capacitor that goes here. We have resistor surface mount that goes here. Then we have the rest of the stuff is through hole. So we're just going to set this part aside for now. I think we should first, let's switch back over to our overhead view. Yeah, we should first get the, I thought I heard a weird sound. First do the surface mount, and then go on to doing the through hole. Because it'll be harder to do the surface mount when there are big components blocking the way. And we only have 3 of them to do, so it's not really a big deal. So, yeah, actually, let me switch back over to this so that I can drop down this camera. Because it's a little too high for what we're doing. There we go. Stop wobbling, please. All right, perfect. So let's get everything into position. Yeah. Unfortunately, yeah. I guess I could have thought this through a little harder, but again, at the rate I have to move in order to keep all these things on schedule, it's I have to acknowledge that I'm gonna end up making mistakes. There just isn't enough time to think everything through and do everything properly. Measure twice, cut once is the rule, but sometimes you just don't have the time to measure twice. So you have to measure once, and then if you make a bad cut, you just have to live with it, because it's all the time you had. The nature of the game. Cyberdeck Cafe, welcome to the chat. That's the that is probably boot disc of the Cyberdeck community. Pretty righteous gentleman. They do their own stream. They have like a podcast thing going. It's pretty fun. I've hung out a couple times. Somebody taught everyone how to use chroma key. Like someone taught everyone how to use a blue screen, and how to change how to like 3D a face onto your face. And since then, their show has gone completely off the rails. And I love it. I love every second of it. These are 330 microfarad, 10 volt. 330 microfarad, 10 volt tantalum capacitors. That's why I didn't want to buy more of them. I wanted to use my stock because tantalum is a conflict mineral, and unfortunately there are times when electrolytic cap just won't work. But the responsible thing to do is to use as little of it as possible. So let's see if we're lined up well to get a good shot of this. All right. So let's get our tip. Let us clean our tip, just the tip. I definitely want to move the tendies out of here. Don't want any flux getting on them. That would be bad eats. So let's give this a little swipe-a-reno. All right. Hold this down. Solder one side. Solder the other side. Need more solder. These are big pads. There we go. Tantalum capacitors they're used. Yeah, they're they have large values, and they're used in circumstances where electrolytic. So typically, I mean, technically they're all electrolytic capacitors, but when I say electrolytic capacitors, I'm talking about aluminum electrolytic, which are the can-shaped ones, the cylindrical ones. And those are almost always a better choice than tantalum caps. But for something like this, we need to keep it fairly low profile. We also need to have a low... Oh, what the hell is it called? A low what the hell? ESR, equivalent series resistance. Basically, we're counting on this capacitor to smooth out the voltage ripples created by the motor running. And, yeah, a low ESR 330-ish microfarad electrolytic cap would be a little too chunky. So that's why we're using tantalum. I also already had them, and you know, waste not, want not. Oh, let's move this back into position. Folks can actually see what's going on. There we go. One side, the other side. It's not worth, but like, yeah, I could bust out the. I could like apply solder paste and, you know, use the hot air gun, but I figured it wasn't worth busting out all that equipment and waiting all that time just to solder 3 things. Where'd the resistor go? Did I like sweep it away when I was moving stuff around? Well, not to worry, I have plenty of spares. My rule is always get, whenever you order parts for a project, always get 2 extra or 20% extra, whichever is greater. And that helps make sure that even when you mess stuff up, you always have at least a couple of do-overs. One do-over off. Oh, I already put it in position. Oh, all right. Well, there you go. That's why I couldn't find it, because I already put it on the board. There we go. One side, other side. There we go. That concludes the service mount part. The purpose of... There we go. All right, rad. The purpose of the 5.1K resistors is to signal to the power bank that this thing wants 1 amp of current. Otherwise, it wouldn't provide a lot of current, and the motor might stall or cause the thing to reset. So yeah, now for the through-hole part. So we've already got our spring terminals. We have our USB. We're going to need our motor driver. Let's see. I think I have that in my I think I have one in my I/O modules section. Yep, there we go. Palalu driver. We're not going to use their included headers. We're going to use the low profile ones on account of them being lower profile. All right, let's pull out a teensy from our stash of teensies. And let's put this thing together. Yeah. Now I could solder this directly down, right? Like I don't strictly speaking need the mating headers, but I would prefer to use a socket because in case I mess stuff up. Got to be careful not to put myself in a situation where I can mess up in a way that I can't get myself out of, because again, I have no time to spin another round of boards. So I have to make sure this has the highest chance of succeeding right from the get-go. I know what I said. All right, so let's chuck this in. We're going to have to rearrange the camera a little bit. There we go. Oh, check this out. Check this out. This thing even has a little lift on it. I could even raise the camera. Oh, look at that. All the things you can get for $100 on Amazon. Let's see. Hopefully it doesn't wobble too much. I have optical stabilization going. What's going on here? Why isn't it lightening up? Oh, all right. There we go. There we go. Yeah, we got optical stabilization going, but it still comes down to how much I whack the table with my knee. You can see I put credits on the back. Very important. Whenever you make a circuit board, always put your name and whoever made the put your name and whoever, if it was commissioned or something. I'm not installing them on this side. I know. I'm just using this to remember which ones I have put down, which ones I still need to. All right. Let's see. This guy goes here. We're gonna put this here. Let's see. Eventually, we'll set up like a little assembly line type deal. Then we need 5 to fill in that gap. Like when it comes time to build a bunch of these, then we'll start like, breaking them. We'll break the headers apart en masse and all that, but we don't want to get ahead of ourselves. We don't yet know what mistakes are in the design. I was going to say I don't yet know if I made mistakes, but I know I made mistakes. So it comes down to what mistakes. So now we need a single header. I can't cut that off by hand, so let's bust out the clippers. All right. So now let's solder these from below. That's why I've got. Let's move this over here so everything's synced up. So I've got helping hands on my pan of ice, so that I can get them up underneath and use them to hold headers in position. There we go. Doesn't have to be lined up perfectly. You know what? I'm thinking about it. Probably makes more sense instead of soldering the headers in there. Yep. Makes more sense. Instead of going straight to soldering the headers, we instead solder headers to the module. This is auto-focusing. Come on. Every time I open OBS, it resets all of my video settings. So every single episode, I keep forgetting that before streaming starts, I have to open up every camera one by one and turn off autofocus. There are so many things to remember. My flight check is like 50 items long. Oh boy, everything involved here is so difficult. Not that I'm complaining, this job rules, but still. Alright. So yeah. We're going to solder on. We're going to solder these onto the module, and we can use that. We can use the module itself to hold everything in position. I'm just going to rest them here on top, and let's do some soldering. Going to rest it here. Let's get our helping hand out of the way. There we go. So I recommend starting from the corners. Yep, I'm gonna start from the corners. There we go. Just gonna press this down as I soften up the solder, and that should realign everything to be roughly 90 degrees. Beautiful. All right, and let's do the rest. Let's quickly check on the boat real quick. Looks like our boat's doing well. Yeah, it's looking solid. This I'm impressed with this this high temperature filament. Like it seemed really scary, but once I got the printer stable at those temperatures, the filament on the whole, except for carbon fiber peak, has actually been very easy to print. I've had a pretty easy time all in all. That said, I haven't been making, we're printing Benchies, which aren't very large. But, using this for stuff like gears, I think it's pretty, it's impressive stuff. Plus, I like large, I think, I'm going to say, I like large numbers, and it's kind of cool to say, yeah, I printed this at 400 Celsius. But everyone, come on, we're all nerds. We all love large numbers. All right, so now we have our modules. Now we have our modules soldered up. So I'm just going to fit the. Did I mess it up again? Nope. Nope, we're right. I'm going to fit the sockets, the female headers, onto the male headers. And that will keep them in place. And let's just double check that we put this on in the right orientation. I drew an arrow, but I don't know what that corresponds to. So this is going to be our ground. Did I set this up upside down? Did I make a mistake here? Because it looks like, because this pin I'm seeing is ground. Right? But that's this pin right here. So I think I set this up upside down. I think I made a mistake here. Oh boy. Man, I just cannot win. Oh, that would make this V motor. V motor, yeah. So it looks like I did this upside down. Alright. So alright. Problem here. So, alright, we're going to solder this, and I'm just going to remove the module. Alright, I did do it upside down intentionally because the thermal pad that, yeah, because like the thermal pad that relieves some of the heat is on the other side. So I guess I really wish they put the thermal pad and the current adjustment switch, or the current adjustment potentiometer, on the same side. Though I don't think I really have to worry that much about the current, about like, you know, fiddling with that pot too much, because current consumption here is quite low. So, all right, well, we'll solder this up, and then we'll remove the module and solder up a fresh one. Yep. This is the difference between prototyping and product development, really. Or a difference between prototyping, short-run production, and proper manufacturing. Is that in prototyping, you just want that thing to look like it's working as rapidly as possible. For production, you want to make sure every possible decision has been made as optimally as possible. Every penny's been accounted for. Every foot of the supply chain has been thought through. And somewhere in the middle, it's complete anarchy. You don't have enough time to think through you don't have enough time to think everything through, but at the same time, you can't make too many mistakes, or you'll have major problems. Of course, as is tradition, we bent all the pins as we pulled it out of these Swiss headers. Don't worry. We can bend these back into place a number of times before they snap off. Trust me, I'm a professional. All right, so we can't use this one. We're just going to set it aside. Don't worry, we'll either desolder those later, or I'll use that in my own project. So this we know works. Very nice. So I'm going to I'm going to socket in the headers. Let's see. Yeah, these already have the pin headers installed from the previous project I salvaged them from. These teensies are actually from, make sure that's cut, it sure is. These are actually from a past client's project. They had a brilliant idea, and I implemented it. I made 20 copies of it, and it worked fine. And then they decided that they wanted to do it a different way, and I ended up with all of the prototypes. So that was a lot of work, a lot of late nights that didn't end up getting used, which, you know, it's not the nicest feeling. But you got to remember why you're doing it. You can't get too wrapped up in clients' projects, because again, they're not your project. You have no interest. You have no vested interest in them. And they're someone else's project, besides the amount they pay you for them. Alienating, yes, but you know, that's what hobby projects are for. That's why I continue to work on my own projects, even as I took clients. Because there's certain aspects of the development process that you just don't get when you're working for other people. What you do get is apparently a bunch of teensies, because ended up not going through with that. Was that a smart idea? I don't know. At the end of the day, like, only the client knows their. This is analog reference. Do we care about this? Yeah, I think. Do we care about the analog reference pin? No, we don't. We can just leave this one off. Cool. At the end of the day, only the client knows how their business strategy. So I can only comment on like the stuff I'm making for them. All right, let's. Nobody notices Mark's theory of alienation. I'm pretty sure if I like say, I'm pretty sure like, I don't know. I think anything anything Karl Marx related is one of those like toxic topics where like you say like no matter what you say about it, like a whole bunch of the audience loses their friggin' minds. I guess like the only thing I'd say is that I think he was a really Marx doesn't get enough credit for being a good economist. He was actually I mean that's what he did. He was he was a really solid economist. And he also combined he was one of the first to combine economic theory with anthropology, which is something you're starting to see more nowadays, in part from behavioral economics, etc. So in that respect, he was way ahead of his time. I'm not, as a political thinker, I don't know enough about it. It's advanced stuff, but I think a lot of people, like, I guess what I'm saying is, a lot of folks dismiss everything he says out of hand, and I think that's a mistake. Because especially the concept of alienation, the nature of unions and worker cooperation, I think that's really important. Can we really run an entire world through people genuinely caring about each other and fairly dividing stuff? I don't know. I think I'm not. Yeah, I don't know. You have worker co-ops and kibbutzim on one side, and you have literally every communist country on the other side. I don't know. I guess folks aren't here to talk about politics. I do think it's the reason I'm harping on this is because he recognized that people working on things they care about and being able to kind of like keep what they make, sort of like people having a real interest in the things they make and having pride in not pride in ownership but pride in fabrication. He recognized that was an important part of the workplace. And, like, that's relevant to all of us makers. Because, again, like, if you're making stuff for the joy of making, right, if you're not being paid for it, like, I think it's an important aspect of the process that if you're too wrapped up in if people are too wrapped up in the money, they miss out on. Like, I love my grandpa, but he was constantly asking, like, okay, you built this heads-up display thing. How are you going to make money on it? You made that glove. Oh, that's really neat. When are you going to get the patent? I kept trying to explain that, like, the business didn't, like, the money didn't work on it, and trying to bring money into it would actually be a net negative. It would detract it. It would detract from it. So let's see. Now we have the USB-C. I don't know. Seems relevant. Yeah. It's like that, oh man, it's like that episode of Rick and Morty where it's like the parody of Something Wicked This Way Comes, where the devil rolls into town and sells people cursed objects, and Rick makes a fortune fixing the curses so people can just have cool stuff, and eventually it's like a real business, and he quits and burns the place down. That hits me. It hits me deep. All right, so now you have the USB. These pads are very close together. First I'm going to do the support tabs, like the mechanical tabs, to keep it in place while I do the rest. But then I don't think there's really any way around this. I think we're just going to have to solder them as best we can. It's going to bridge like crazy, and we're just going to use some solder wick to slurp up the excess. Because we have to really get a ton of solder in there. We got to make sure the solder goes all the way inside. All the way in there. Another Rick and Morty reference. Man, that show is really good. That Justin Roiland is so friggin' funny. If you have a VR headset, you gotta play Justin Roiland's VR games. They are so funny. Like accounting and was it the Adventures of something or other? I forget. Anyways, they're funny as hell. think like in VR accounting, like I think in the first 5 minutes you burn down a forest and then have to cut a VR headset out of a guy's chest. Yeah. It's pretty much exactly what you'd expect. All right, so looks like there are no shorts here. Eat my shorts. Looking good. All right, and last thing is the spring terminal that we're going to connect the stepper to. Yeah. No, I don't have a particular reason for using a spring terminal over using. Now let's switch back to the overhead. Let's let's spice it up a little bit. I don't have any real reason to use spring terminals over screw terminals. I just already had a bunch of them on hand. You know, waste not, want not. See these were smart. These guys are smart. They put a dog leg in the pins, right? They made the pins like a little crooked, so they stay put. We don't have to worry about holding them on the other side. So they'll stay input as we they'll stay input as we solder. That's right. They'll stay put as we solder. All right, excellent. And we're just going to pretend the motor driver module is there. All right, so I'll leave that hot for a sec. I think we should do a test fit. We only managed to print half of the. Only managed to print half of it, but it looks like all the dimensions made it, or it looks like all the parts with the dimensions we care about made it. So, yeah. So we have nearly all of this, which is good. We should be able to test fit everything, including the battery pack. So, yeah. Let's grab myself some pliers. Let's see if did I miss anything. Have I missed any super chats? Have I missed anyone? Have I missed anyone becoming a patron? Yes, Rainbow Orange. Yeah, Rainbow Orange is our newest patron. Thank you so much for joining during the stream. I really appreciate it. Really appreciate the support. Oh, of course, speaking of the support, today's episode is sponsored by Things. Yeah, no matter what kind of 3D printing you do, whether it's bootleg Warhammer minis or doing nothing but printing things that improve your 3D printer, whatever you're looking for, you're going to find on things.com. And if you can't find on things.com, Things still searches a whole bunch of other 3D print websites. So, yeah, super easy website to use, super fast, doesn't keep you waiting for a few seconds watching an ad before you download anything. Doesn't, everything on it is free, and the site itself is free. So yeah, if you 3D print on the regs, definitely make sure to use the link in the description, support the channel, find something new. And while you're down there, make sure you visit my profile and download everything that I have ever uploaded to Things, because I put most of the stuff I make for the channel on Things. So yeah, thanks a lot to Things for sponsoring the episode. It's been a huge help to the channel. This is a client project, so it's unfortunately not going to end up on Things, but the heads up, the bad heads up display from the recent episode is up there. I never got around to making the instructions for that. I am so underwater. I have forgotten what daylight. I'm so far underwater with my to-do list. I've forgotten what fresh air even tastes like. So let's see. Just gonna clean this up a little bit. Looks like my XY separation wasn't that good. This is a pretty old spool of filament. This is some inland PLA that I think I actually borrowed from the Fab Lab. So yeah, I think I actually borrowed that from the Fat Cat Fab Lab before I moved. So this is some pretty old filament. Why am I appropriating filament from the Fab Lab? Well, because the Fat Cat Fab Lab has 3 excellent printers that people use all the time. They're Ultimakers. They use 2.85 millimeter filament, and people keep donating their filament. Like when they're done with the project, they'll donate the spare filament, like from their home printer. So the Fab Lab has like an entire table just full coast to coast of 1.75 millimeter filament that they didn't know what to deal with. They didn't know what to do with. So I would I would buy 2.85 millimeter filament and trade them to keep that stuff from going to waste. And this is I think a very old spool of a very old spool of Inland filament. I think it's Micro Center store brand. There we go. I gotta get these bits out because I want to test fit the circuit board, and it's not going to fit if there are bits of plastic cluttering it up. This is what the gyroid infill looks like. It's making some sounds. Yeah, this filament's got problems. Still don't have the Viper. I printed this on the Anycubic Viper, and I still don't have that dialed in exactly right. The E-steps are better, but I don't know. I can't explain what's going wrong with it. It's just the prints are like off. Can't really point to anything specific, but it's just stuff like this, like the filaments, support materials not detaching properly, you know, all that. Yeah, what's it? Thangs. That's right, Thangs. I should. Evan Cleary says you should say your sponsor's name right. Thangs. I like to think that at the I think they just raised like a Series B. I like to think that at the pitch meeting, they were like, ladies and gentlemen of Anderson Horowitz, today we have a very exciting opportunity for you, thehangs.com. I don't know, that just tickles me. Oh man, VCs must have the weirdest variety of like the way people treat them. Like they must deal with this combination of both like super business-like types, you know, come in wearing suits and, you know, are super formal and uptight, and Silicon Valley coder dude bros who are, you know, show up in the middle of summer wearing 2 hoodies and try to invite them to crush some brewskis after work or whatever the programmers do. Yeah, that must be kind of fun. You know, some combination of like ultra confident people, like ultra confident startup founders who read Guy Kawasaki's book and are like being super macho, and then you have like people who have actually started their company and received their funding who are like freaking out all the time, like nervous wrecks. Yeah, VCs must see like a real cross section of the human experience. Looks like we're still printing. All right. Looking good. Haven't jammed or anything. Very nice. Okay, so we've cleared away all the crud. Let's see. Joseph Hutch is asking Brooke, but I'll answer. How's the smoke in Denver? I'm west of you, and visibility is about 1 kilometer. The smoke is totally noticeable. I had the other day. I was walking the pups, and I had no idea what the hell was going on. I thought it was just a really, really, really heavy fog out of nowhere. Okay, so looks like our micro USB port is looks like the hole we cut out for the micro USB port is a little off center. I need to find the micro USB or the USB-C. I said micro USB, I meant USB-C. So let's try plugging in the USB-C cable and see if it fits. So looks like barely. We do want to. So we can't get away with leaving this in there. We have to fix it. But otherwise, this looks all right. So we'll be able to get a micro USB cable in here to program it. Looks like we can raise this up a little bit. This is too low. So we have things to do. So I'm going to grab a brightly colored marker, and I'm going to start marking this thing up. So this we want to move upwards. Let's see. We want this to go inwards. Or nope. Wait. We want it to go outwards. Yep. Let's see, we want this to go inwards. All right, so we can't bottom out our motor. I'm already fairly sure the motor's going to fit, though. Where did I end up putting it? Oh, I'm seeing some cables. Pretty sure the motor's going to fit, but yeah, so we can't bottom it out because it didn't print all the way. But, you know, we can still hold everything in position. So the wires get routed in like so, and they have plenty of room, so it looks like we're good here. You know what? We can probably move these in a little bit too, because this hole is just too big across the board. Could probably tighten this up a little. It says about 1 millimeter of play, and I think that's, yeah, I want more support. So I'm just gonna mark this, move inwards. All right, let's see if the battery pack fits. Before, I made the hole for the battery pack far too small, so I enlarged that. Let's just see if this fits. Ah, there we go, like a glove. It's not even top heavy. This I don't like, though. Yeah, this here I'm not a fan of. The wire is a little, yeah, the wire is a little too long. So, question is it worth the time building someplace to wind it? I don't think so. I think we're better off just, yeah, I don't think so. I think we're better off just attaching something to the back of the USB battery pack, like a cable clip or something, and holding it there. Yeah, cool. I've got this place on top for a nameplate that I will probably make on the laser later. But otherwise, I think this looks pretty solid. Looks pretty righteous. So next thing to do is to test. Gotta get that firmware onto there, and or gotta get some basic firmware onto there, and just make sure this thing can drive the motors. All right. So the problem we had before is that I soldered this backwards. This side should be up. I don't think that's the smartest decision, but you know, I work what we can get. Work with what we got. Casey Effner says, good-looking case. I would trust someone named Casey to advise me on my cases. Yeah. Ryan 3003 says, will the tool changer's touchscreen mount be available on things? Son of a bitch. I never put any of the tool changer mods anywhere. Maybe we should spend a couple minutes today and do that. I'll put that. That's now on the to-do list. All right, I'm going to grab myself another motor driver module out of my box of 24. Here we go. Yeah, bought 24 of them because, again, 20% or 2 extra. Here we go. Some folks are, let's see, Luca Morcelli is asking, what is this? This is my very last client project. It's a piece of motorized art. It's basically a hub to mount a large circular art piece that subtly spins it, so that as people come back and look at the same piece over and over again, it changes very, very subtly. It's a pretty cool concept, if you ask me. But yeah, this is my very last client project. I almost made it to a decade in the business. Almost. But then a certain virus kind of put the kibosh on that, and now I'm doing YouTube. But the YouTube thing got big before I finished all my clients, and now only one remains. And the gallery opens in September, so I have to finish all 20 of these things by September, by the end of the month, in addition to doing all of the content that you find folks expect of me. So yeah, this should go down like so. Yeah, I don't think this is the smartest. I think I did it like this, so if I needed a heat sink, I wouldn't have to change anything. Yeah. Let's get this battery out of here. We don't want a USB pack around when we're soldering. That seems like a great way to reduce the number of the amount of my body covered in skin. Yeah. So again, we're going to solder corners first. Having a much harder time now because the pins are acting like heat sinks. There we go. All right. That was unpleasant. All right. I was watching one of man, I was going to watch Joel's stream last night. I was going to watch 3D Printing Nerd, but I had the time wrong. I forgot to account for the time zone, so I missed it by by a few hours. It's really unfortunate. It was, anyways. Like the reason I bring it up is because I saw a whole bunch of names on Joel's stream that I see on our stream all the time, and that was really sick. It's really neat to see that the various communities overlap. That folks are folks are just into 3D printing that much. So let's solder this up. This is a stepper driver module here, which is convenient because we got a stepper. The reason why I'm using this particular one is because it does really nice micro stepping, and it's important because we want this thing to be as quiet as possible as it's revving up. Remember, this is going in a gallery. Like there gonna be like 20 of these things going in an art gallery. So if it makes any significant amount of noise, it's going to just stack up and turn into a cacophony. So caca. So we have to make sure that each one is as whisper quiet as we can, and I think this is the way to do it. So that's it. That's the board. This is a very simple board, all things considered. Now I guess we do the smoke test. We plug it in, and if we see smoke, it fails the test. That's how it works. First, we should also plug in. This one already has a. You know what? We're gonna leave. So we already have the prototype here. We basically just implemented the prototype in a circuit board. There's really nothing special going on here. We're not gonna do anything fancy like add ferrules to these, because they're only supposed to be installed a single time. So I'm not that worried about finishing the wires. So we'll just install those. So from the bottom, we've got, see, black wire. Yeah, these wires, even though they use the same wires as like color, even though the colors are kind of like loaded because of color coding, they don't signify anything. They're just or rather they don't signify like voltage, ground, etc. They're just like, A coil, B coil, etc. The way steppers work. Steppers are pretty cool. Ah, jeez. Yeah, steppers and brushless motors in general are pretty sick. So these spring terminals don't need any tools. We can just hold it down with our thumb, which is going to come in handy when we're putting the thing together, because we're going to have to like reach in there and push it down. Okay, so blue, red, green, black, blue, red, green, black. Excellent. Okay, so we're wired up. Let's see. How do we want to do this? Yeah, because my isolated USB hub possibly is dead. Maybe we should take a detour and wire that bastard back up. Then I have to like set it up and everything. We can just try plugging this thing in and just see what happens. Alternately, all right, we could do it. Do it properly. Where's my... All right, let's find the... Here it is. This thing is a... So this is USB... This is a USB extension cable, basically, that lets me jumper the wires. So, like, it lets me pull a jumper and insert, like, current probes or something. Yeah. We don't need soldering iron anymore. Insert current probes or whatnot. So, what we're going to do is we're going to connect this thing to power, right? But we're going to do it through this. So we're going to hook up a... oh, crap. I can't use my meter. I forgot it ran out of battery, and I don't have another 9-volt. I completely forgot to get another one. All right. Now, well, we're not going to be able to keep an eye on our current draw then. We're just going to have to wire this thing up and hope for the best. Let's see. I guess we could try to reassemble this thing. All right. So here's our Here's our USB. Let's check on our print. Oh, that boat's looking solid. That's looking like a... Let's full screen that. This boat's coming together. This thing's looking pretty good. As I've heard in a lot of different places, PEC is supposed to be the easiest to print of the high-temperature filaments. And it seems to be living up to its reputation. As far as I can tell, it hasn't even knocked the booger off. That looks pretty good. Let's see. Max says, no meter, stick an oscilloscope across a very low-value resistor. And then I'll have to, like, hook up alligator probes and whatnot. It doesn't matter. Like, the exact current draw doesn't matter. I just want to know if it's shorting. But, okay, let's see. So, smell test, nothing. Not seeing anything burned. Are these, ESP? No, different. Oh, it's a global part. Is the logo on here? The logo on this thing looks very similar to the ESP, like from the Espressifs, like the ESP8266 and something. Let's show you that here. There we go. Yeah, it looks like the ESP8266 logo. So this is a really fancy USB hub, and it's got all kinds of like it's got like protection diodes across each voltage, line. It's got a ferrite bead on the ground. It's got like protection here. Oh, let's try to get this in view. Yeah, it's got protection here. These are diodes for the digital pins. So it should be fairly well protected. I'm not seeing any damage, so I'm guessing that this thing is still working. When I tested it before, it did heat up a little bit though. So let's see. Let's plug it in and see what happens. If it catches fire, then it's probably broken. So let's see. Just gonna power it up here and plug it in. Ouch. Yeah, the USB hub chips heated up. Yeah, these things are really hot. I don't know if they're just supposed to run hot, but that seems too hot. I mean, this is like finger scorching hot as soon as I turn it on. I think it may have. I think the surge may have blown them out. I think this. Ow. Yeah, that's way too hot. Oh well. Womp womp. So let's get this out of here. Probably gonna salvage parts from that because it has like a bunch of USB-C stuff. All right, so we've got. All right, so in that case, I'm gonna scooch back over. Let's see, I'm gonna scooch back over here to our chair. Bear with me one sec. Scooch back over here to the computer section. This is really hard. This place is too jam-packed. Oh, there we go. Okay. So there we go. Okay. So we'll plug this into my main hub over here. We're gonna need a longer cable, and I probably want to try to get this thing in view. We're also going to want to take some tape and put a little flag on it so that you fine folks can actually see when it's rotating. So let's loosen this up. Let's get this in view. Let's see. Now we're overexposed. Beautiful. All right, let's put a little flag on here. There we are. Okay, so we're going to need a micro USB cable. That's right, micro, because we'll power this thing directly off the battery. We'll power this thing right off its USB battery. Don't need my fume extractor anymore. I wish there was some way to like connect them, right? So that like when my soldering iron is on, the fume sucker is on, and when I turn it off, it switches automatically. But all right, let's try hooking this up. Yeah. So if I press this twice, this green light turns on, and then this stays on forever. Nothing's on fire. I'm not smelling anything. All right, that's a good start. Let's move these a little so you can see. Okay, now I'm going to go back to the computer here. All right. Oh, how'd that happen? I seem to have dragged it away. There we go. Yes. Nelly Merck says, I watched the Chromance video, but before I go for a rewatch, does it mention what power supply is used? No, I almost never talk about the components in the... I almost never talk about specs and components in my videos because it causes massive swaths of the audience to instantly leave. But if you check the links in the description, you will find a complete bill of materials as well as instructions. And I believe in one of those that has the... I believe one of those has the power supply that I used. I think it was a fairly beefy one. Please don't explode. Now I'm paranoid. Yeah. It's a pretty beefy one. I think I got mine from Adafruit, but you can get it online. Let's see. Mojo Monkeyfish says, what's your longest brick combo where you've bricked stuff... Trying to fix stuff you've bricked. I have never bricked something twice trying to fix it, because I generally, if I mess it up the first time, I'll usually just replace it, because you know time is important. Let's see. Yeah, time is important, but what was I saying? I am so friggin' tired. These dogs were barking. These dogs are barking like all night and all morning, and I have like 2 hours of sleep. All right, what the hell was I doing? Oh, right, we're going to open up Arduino, and we were going to put some code onto this to try to get this whole flag to spin. And I can't remember if we already had firmware written. Let's see. I'm going to open up my file here. Doesn't look like it. Look, so we were probably just running... Let's see, so we were probably just running the, like some example sketch. No, that's not what I want. There we go. Now no one can see anything. Oh, man. Yeah, no one can see anything here. All right, so let me open up settings, and let's switch the display density so you folks can see it. This is another one of those things that I keep forgetting to do before I start the stream. All right. What was I running on? What was I running here? This is... What's this thing called? This thing is the Palalu... What does that say? Oh, the friggin' solder mask isn't... Like, the silk screen is all flaked. MD39A? I think that's what it's called. It's called the MD39A. Teensy. Okay, open. There's nothing here recent. Okay, so let's go to, first off, let's make sure we're not going to overclock the Teensy. 96 megahertz is a little much. We are using a Teensy 3.2 because I just have a lot of them left over. No point buying a bunch of expensive micros if we're not going to use the processing power, and if I have a bunch of 3.2s sitting around doing a whole lot of nothing. So, yeah, let's see. I forget what the library for this thing was called. If we just use Stepper or what? Palalu MD39A? I'm not seeing anything for P for Palalu. MD39A, no. Palalu, po. I can't scroll down any further. All right, I'm gonna close Arduino and reopen it because when we change density, weird things happened. Let's see. Ugo says it's Palalu, not Palalu. That's what I said. Or is it Palolu? I don't. Did I mess it? Did I mess that up? Is it Palolu, not Palalu? All right. Okay, so don't worry, folks. We are not. Don't leave. Stay put. Don't run. We are not going to be. All right, here's how. It's currently 2:30. At 2:40, coding is over. No matter what we have, we're moving on. So I'm giving myself, we're time boxing this, giving myself exactly 10 minutes to get some sort of usable code running on this. And after 10 minutes, we're going to go back to doing 3D printing. And you're going to have, we'll have stuff to watch. So don't worry, we're not going to be struggling with this indefinitely. I am, in fact, tell you what, I'm going to open up the alarm app. I've already wasted 1 minute explaining this. And we're going to go to timer. We're going to give myself 9 minutes. There we go. And we're going to move this over here. Okay, so let's go here and let's see. Arduino, Palu, what was this thing called? The MD39A. Yeah, my memory is not very good because of how sleep deprived I am. Okay, here we go. STS PIN 220 low voltage stepper motor driver carrier. All right. So does it have recommendations for programming it? Because obviously I've done this in the past. I just don't remember what I did. Because, yeah. FAQs. Is that where this is going to be? I want to control motor. Do I need to set a current limit? It's overheating. All right. How do I use this on Arduino? Let's see. All right, so maybe if I type in the right thing, STS PIN 220. All right, the driver will not supply the full current. Well, that's not what I'm looking for. What do I do? Let's see. Okay, I have 8 minutes left. All right. Used as a drop-in replacement. So is this just like we just hit the step, like we just have a step pin and a. Pardon me for not reading chat. I don't really have. I have to be very careful with my time here. So let's go to maybe there's just a global example for steppers, because this seems like it's just a. Yeah, it seems like it's. Let's see. It seems like it's just a pretty straightforward board. So let's see. I still can't read what's. Oh man, I still can't get to the bottom of the. Still can't get to the bottom of the list. So if it is there, I can't see it. Crap. 7 minutes. All right. We're going to. All right. I have to switch the switch our resolution back so that I can open the. I can open this menu and see what's going on. Stepper. There we go. Stepper. Call this one step at a time. Why do people name things like this? Like the purpose. Why do they call it one step at a time? Like the whole purpose of this is for like people are in a hurry and they want to get moving right now. So why would you give it a poetic name? That's just so obnoxious. I hate whoever wrote that. I'm gonna git blame it and figure out who wrote that. Okay, let's see. Initialize the stepper library in pins 8 through 11. Don't tell me what those pins actually do. This is why I love. That's why I love Python. Named parameters should be mandatory. I'm a strong believer. I'm a strong believer in that. It's a hill I will die on. All right. Well, that's not helping me. How much time do we have? We have 5 minutes. Got to get a move on. Oh, we got a super chat. Sean, thank you so much for the very generous super chat. Looks like you're trying to code. Be a shame if you had a donation distraction. Indeed it would. I really appreciate the very generous super chat. Thank you so much for supporting the channel. Let's see. So we've got to open, first let's check the file itself, stepper.h. Let's check the header file itself, and let's see what, nobody can see anything because I turned the display density back down, so let's turn it back up. All right. Sequence of control signals is as follows. All right, so we got a constructor. 1, 2, 3, 4, 5. Okay, so we've got a number of steps followed by motor pins. I don't know what the numbering scheme is, so we are going... Motors attached to digital pins. Wait, you can't attach a digital pin. What? attach a motor directly to a pin. What the is this like driving it off of like MOSFETs? I think we got the wrong thing. All right, let me open up my. All right, we got 3.5 minutes. Let me open up my schematic. What did I call this? I called this Fusion Mandala. All right, open up the schematic, and let's refer back here. So we have an enable line M1 and 2. Those I don't remember what any of these things do. Yeah, all right. You know what? We're scrapping this. We're bailing early. I am not prepared. I didn't write down. I didn't prepare in advance what everything is supposed to do. So yeah, there's no way for me. Unfortunately, there's no way for me to make this entertaining. So we're bailing. Right. Let's turn our attention over to the other 3D printer. I just realized I never set up a view for it because I am dumb. Bear with me one sec. Don't worry, I'm gonna be. This is gonna go quiet for about 5 seconds until I. You're gonna go quiet for about 5 seconds. As soon as I add in the overlay with all of our information here, it will also bring back the voice. All right, 5 seconds of silence, which does not mean your audio isn't working. Doesn't mean my audio is not working. It's a-okay. This is by intention, by design. I'm doing this on purpose. 5 seconds of silence, and darkness begins right now. All right, we're back. Excellent. So now all I have to do is add the Printer Vision Sultan of Squirt. What's going on here? Why is the resolution so weird? No. Why are you doing this? Why are you doing this, webcam? Why are you doing it to these poor people? There we go. 1920 by... Oh, man. What happened here? We want... Fuck, I can't... Crap, I can't see anything. Tools. Don't worry, we will be printing in no time. We're going to reset transform. There we go. Now it's blocking everything, but that's okay. We just drag it down, and we are set. All right. So the filament we are going to be using now is called Reflectolay. In fact, I'm going to grab it so I can show it to you, because this is one of the coolest filaments that I got for this episode. Yeah, this is one of the coolest filaments that I got. It's really sick. I'm super excited about it, and yeah, so I've been saving it specifically so that I can show you folks as we print it. We are gonna have to respool that, but it's fine. It's fine. Everything's fine, and I'll explain why. Because this is a flexible filament, right? You know, all right, fine, whatever, nothing special. Okay, but that's not the cool part. The cool part of the Reflectolay, you might be like, oh, it's reflective. Yeah, look how smart I am. No, but you're wrong. It's not reflective. Your presumption would be incorrect. It's not reflective. It's retroreflective. So check that out. See those little dots? Those are the same retroreflective material used in like road signs, street paints, and all kinds of other stuff that reflects light directly back wherever it comes out from. So anything printed in this filament, if you try to take a picture of it with a flash, with a camera flash, it should blow it out. So we should make a paparazzi-proof Benchy. Yeah, it's gonna be just what I think it's neat. So let's respool this, and then we will look up how to. Oh, we're gonna respool this, and then we're gonna look up how to do it. By the way, don't worry. Like, I know I have a habit of not finishing projects. All we're gonna do here is I'm just going to confirm. Hang on a second, it's not going to work. I said I was going to say that, like, I'm just going to remove the teensy from the prototype and put it here, but I switched some wires around. So unfortunately, maybe we'll mess around with that again near the end. Yep, that's it. We're out of time. Yeah, it just wasn't. Boop. There we go. Yeah, it just wasn't meant to be for now. I have a tendency, you know, like. It's a way of saying it. I'm not a professional entertainer. Like I guess I'm a professional entertainer, but I wasn't trained for it, so I'm still learning the ropes, and still getting a handle on what level of prep I need. But yeah, it's very easy for me. Like, I don't know. Like, I'm motivated by the projects, right? Like the project. Like, I want to work on the projects, but it's important for me to remember that, like, if you're doing YouTube or something, it's not about me. What I want is of partial, kind of minimal concern. It's not about what I want to make, it's about what you want to see. So, as much as I love making projects and getting and finishing stuff, the important part is to make the show fun for you to watch. And watching me struggle to figure out how to drive a stepper is, well, statistically, it's bad entertainment. So, let's see. Yeah. This, I'm not worried too much. There's no chance this is gonna break. Like, watch it break. But seriously, like, I'm being rough with this because it's super floppy. I've heard that the Hemorrhas, right, the Hemorrha extruder, is really good at handling flexible filaments. I haven't seen that firsthand. I have not been able to get this tool changer to print anything flexible. It has been failing every way you can think of. It's been failing like crazy. The Prussia's fine. The Prussia's been doing a great job. Prussia's been doing a great job printing all kinds of flexible filament. And with this filament was, of all of the filaments that I have in this episode, this one was the hardest to get a hold of. I had to shop around to dozens of places before I found one that actually still had this reflectolay in 1.75 millimeter in stock. Even then, like, this, I think 50-gram sample spool was ungodly expensive. It was like $35, $50 or something. So I only bought one of them. So it is of critical importance that this boat works on the first try. So we're going to be super cautious here. I'm being careful to respool it. I'm going to be running it in the printer that I think is the highest chance of success. We're going to be super careful. I think we'll print it at, normally I'd print it at a low speed, but that doesn't always work with flexible filaments. We're going to read the instructions. We're going to be super careful about this. But hopefully we end up with, as far as I know, the only retro-reflective Benchy. Yeah, it's kind of cool, isn't it? All right, so we've got the filament. I'm just going to trim the end off. I'm just going to clip the end off. And yeah, I'm not even going to load it yet. We're going to turn this back around. I've really got to get another face cam, so I don't have to keep turning my monitor around. I knocked my body pack off. Get back on there. Yeah, and let's look up info about this filament. Here we go. I know you folks don't like looking at all the tabs I have, so let's open up a new one. Right, so let's see. Reflect Olay. I had to buy it from, I think, Poland. I think this place in Poland had it in stock. Yeah, look at that. This is what we have. I did not pay oh, this is in London? Maybe I didn't buy it from this. Yeah, this is how much it cost. It was not this. Anyways, let's take a look here. More details. That's what we want. We want more details. The very first truly reflective. Oh, I guess I'm not the first one to make a reflective boat. There's one right here in the product page, and clicking on the images doesn't seem to work. Oh, there we go. All right, so it looks like they beat me to it. So we're not making the very first retroreflective boat. We're making the very second. That's all right. Silver is still a precious metal. Alrighty. How do I print this? Where are the instructions? Can be printed at 210C on a cold bed, rough capped on, or blue tape. Not PEI? That's it? That's the only advice it's giving me? 210 Celsius on a cold bed, rough capped on, or blue tape. All right, this isn't very helpful. Let's go back to the Google. Reflectolay. Yeah, this filament was hard to get a hold of. Matter Hackers says they have it. Oh, right. I would have had to buy 250 grams of it for $50 if I bought it from Matter Hackers, and I don't think was this 1.75? Yeah, so they got this back in stock. This wasn't in stock when I bought it. They don't have any information either. Let's see. I'm having feeding problems. I have a Prusa i3 Mark III. I've set my print move speed to 10mm max, volumetric speed to 10 cubic millimeters per second. It's so flexible, it doesn't push into the heated chamber for the extruder. I tried running the fans to keep the chamber cool, but it didn't help. This is what we're worried about. Lower this. All right, so we want to print this slow. We're gonna go real slow. All right. So let's see. So that's what I'm gathering. We're going to print slow. Do not develop this material and can't comment, yada, yada, yada. All right, we're using a 0.6 nozzle, so we don't have to worry about that. Just being really careful here, because we really have to nail this. So it says we had luck printing at 210, same as PLA. So it looks like it prints at the same, so it's a low temperature flexible material. So this will back up. We want to completely disable retraction here. Let's see. Is this going to be abrasive? It's made of microscopic reflective spheres. That's a link. Check it out. It's under a microscope. That's what this filament looks like under a microscope. Wow, that is a really high density of retroreflective bits. That's really cool. Huh. Okay, so it looks like we're going to run this thing at 210 Celsius, and we are going to, it said blue tape, rough Kapton. So if it's sticking to that stuff, it should probably stick to PEI. So we'll wash it off. It says you don't need to print it. It says we don't need to heat the bed, but I think we're going to do it anyways. We're going to need a release agent, though. Is it going to stick too hard? I suppose there's no way of knowing. Crap. All right. We don't have enough information yet. We have to keep looking. All right. Where's my? Don't worry. We're not stalling out. Everything's fine. We're gonna go back to 10. I'm setting a 10-minute timer. This printer will be moving by the time that timer runs out. We will move forward. It's gonna happen. So, has anyone ever used this filament? Like, is there any information here that is not from people selling the product? Because, yeah, I mean, look, this guy Kai Parthy, he's the guy who makes all the lay filaments. The guy's a friggin' genius. The filaments are so clever. The information, to call the information he provides about how to print the filaments bare bones, is giving him too much credit. There's effectively nothing. If you're lucky, it tells you what temperature to print it at. So what I've been reading so far is like totally like what I'm used to. Or I've seen this before. Oh, look at that. They even have a little diagram of how retroreflective stuff works. All right. I don't want to. Yeah, I don't think we have time to watch the entire video. So maybe there's the information in the video. Where is the printing info? Kai says the 3mm version can be printed 210. The 1.75 flexible filament are more difficult to feed into a hot end than 3mm. Yeah, we got to be careful here. All right, so no extra information. So let's just treat this stuff like PLA and see what happens. I think we're going to leave glue on the bed. Oh, look at that boat. That boat's coming together. We're in the home stretch over there. Looks like we did need to slow it down after all. We probably could have printed even a little quicker. Okay, so let's head over to the... So we already have a piece of Kapton here. What do you think? I mean, it said print on Kapton, so like I guess we could try it. Worst case scenario, it just doesn't work. So let's grab our spool and let's head over here. So the filament that's currently loaded into here is Bendlay Flex. That is it's another Kai Parthy filament. That one was really hard to get to print. It's yeah, that one's really hard to get to print. It was it's flexible PETG. I think that's what it was. Here, let's switch to this so I can look you in the eye while we get all this done. So yeah, the filament that's loaded in right now is flexible PETG. That one was pretty neat. It printed like complete garbage, but I don't have enough filament to do it over because that one was also very hard to get a hold of. So this one should work a little better. I'm printing on the top one instead of the bottom one because I want to be able to keep an eye on this. Flexible filament tends to fail at the drop of a hat, and we can't waste even a single gram of this. So yeah. Let's see. Well, kind of hard to see anything in there, huh? Kind of hard to see anything. So let's log into it. That's the Sultan of Squirt, and I hooked up the overhead lights to G-code. So we can do M42 for activate GPIO pins, P76 for run pin 76, and S0 to set it low, and it turns on. There we go. All right, we're gonna need some cleaning filament. Here we go. That's the stuff. And here's the question that's baffled scientists forever. Are you supposed to turn your extruder tension down or up when you're printing flexible filaments? Because I've heard you're supposed to turn it down, like you're supposed to release tension to keep the filament from getting like mashed into the mechanism. And I've also heard you're supposed to turn it up because you're supposed to turn it up because it might not grab onto it if it's too elastic. So the fight will rage on. I am going to leave it. I'm going to leave it as is. This last filament we were printing was semi-flexible, so I'm going to try reusing the same settings for it. I don't know why you would make this filament flexible. I don't really understand. Maybe it's like some interaction with the. Oh, it looks like we still have a filament on here we haven't printed. It could be like some interaction with the particles. Like maybe they just don't work well on a rigid filament. Yeah. Got a filament here that. Oh man, maybe we'll talk about that one later. It's one I'm really scared of. All right, so I'm just loading in some purge filament. The filament that's currently in here prints at 230 Celsius, but the reflectolay prints at 210. So we're just going to run through some cleaning filament to purge all that out so we don't end up either burning the reflective filament, so we don't burn the reflective filament, and so we don't try to drive it. You know, you can't push a 230 milligram. You can't push a 230 Celsius filament out of the nozzle with a 210, you know, necessarily. So yeah, we're gonna run some purge filament through. I don't actually know what this is made of. Some of them are nylon, but this one definitely isn't. Why can't I close this box of screws? Oh, there we go. Because the little dividers decided to make a break for it. All right, there we go. So we're going to unload the cleaning filament. All right, we're going to load up, and here we go. Let's load up the reflectolay. Oh, cue the Bouncing Souls songs. Oh man, Brooke and I saw Bouncing Souls in concert a while ago, like way before the pandemic. It was all right. Looks like our PLA here is set to 215, so I'm just gonna go to settings. It made it very clear it had to be 210. So I'm gonna go to settings, nozzle, and I'm gonna manually change the temperature down to 210. All right. Cool, cool, cool. While that chills out, let's take a look at. Hang on a second. While that cools off, let's take a look at. We got some super chats here. Blasto Supreme says, Blasto Supreme says, Quagsire on head, please. I'm afraid I can't do that because I already have. Right. Thank you so much for the super chat. Blade of Kitten, thank you so much for the super chat. Hey, Zack, how are you doing? Followed by a big old pile of ducks. I'm doing all right. I'm doing all right. Things are good. Thank you a lot for the super chat. Really appreciate it. And right above it, Aerator says developers of products, documentation is very important. That's 100%. If you make, if your documentation is, people need documentation to use your product. If your documentation sucks, your product is literally useless. If you are trying to sell people things, don't you dare ever have the audacity to think that your product is that good that people will deal with BS to use it. They won't. Your users don't owe you anything. Give them the best the products with the best developer and user experiences are the products that keep getting used. 100%. Let's see. So we have a lot of options, a lot of suggestions here on how to print this material on what bed. I think for now we're going to try. So right now I've got this Kapton. I've got Kapton glue sticked down onto a bed. There's a reason for that. But anyways, we're going to try printing it on the Kapton. If that doesn't work, we're going to rip off the Kapton and try putting on the glue. If that doesn't work, we'll clean off the glue and print straight on the PEI. So we have a whole hierarchy here. All right, I'm going to stop our timer because we are effectively printing right now. So right, we're back down to 210. So let's load that filament. Let's make sure it comes out nice and clean. The Prusa i3 Mark III S and the S Plus are really good at flex materials. I don't know why I've been having so much trouble with the Hemaras. I've heard they're really good at handling flex filaments. All right, so it looks like we're not getting a lot of tension on this. So we're gonna have to. All right, yeah. Oh, it's not putting a lot of tension on the filament. So we are going to have to print very slow. So it's basically the odds of us finishing this on time are basically 0. But we can still get the first few layers down. That's what we're here for, right? We're here to move projects along. We're here to get stuff done. So I'm gonna switch back over to printer vision. There we go. Now it's nice and bright. And let's open up. Let's see here. Let's switch us back. Oh crap! Oh wait, never mind. I thought we ran out of filament, but that was just the loose end of. Oh, we had a break here. Looks like we're getting some bad layer adhesion. Yeah. All right. So this boat's a bust. We'll take a look at that. We'll take a look at that when it's done. But yeah, it looks like this boat's a bust. It fell apart. I think we're gonna have to actually I think I'll actually have to get a heater and heat the chamber because we're getting poor layer adhesion. We might also be moving too fast. Now I'm thinking about it. All right. Look, it's part of the fun. As you can see, this is why I had to do a stream like this, because the stuff I'm working on right now is just so complex and difficult that, it takes time. It is stressful, though. It does feel like I'm at a standstill, and I know that everyone in my everyone needs me to move faster. Doing the best. Brooke says, "Why you do this? Why did I do what? What did I do? What's going on here? Oh yeah, yeah. Oh wait, hang on. Oh, I had my Discord open. I mean, everyone who, I don't think there's any. I didn't leak any information there, did I? I don't think so. Right. Let's realign my chi here. Let's get this guy out of here. You can see that I'm on our Discord. That's right. I actually use it. That's right, I actually use our Discord, and now I've proven it. Okay, so we're going to open up, yeah, look at all this stuff I've got going. All right, we want the one in the coccolith. There we go. All right, we're going to start off with the PLA. We're going to start with the PLA profile, though we have to modify it. So we have a 0.6 millimeter nozzle. Let's reset our detail profile back. We're going to give this a brim. I know I'd prefer not to, but I can't let, we don't want this thing to detach. So we want this thing to go real slow. So I'm thinking we'll max out at 20. So big perimeters are 15 millimeters per second, small is 10, external perimeters are 10 as well. Infill, let's do 20. Solid infill, 20. Top infill, do 15. Support doesn't matter. And bridges, 15, because this likes to. I mean, I assume it's going to flop a lot because it's flexible. All right, travel. Does it matter? Is there any merit in slowing down our travel? I don't think so. First layer speed, we want to do that at, let's call it 10 millimeters per second. Let's really make sure we get that right. Okay, cooling. We probably want 100% cooling. Yeah, we probably want 100% cooling. For filament overrides, though, we want to disable retraction because this is a flexible filament and we don't want it to back up. What else? Is there anything else we want to be careful about here? We probably want to avoid, yeah, here we go. Avoid crossing perimeters. And, let's see. Want to avoid crossing perimeters, and let's see. It's allowed to move up to twice as far now in order to avoid crossing the perimeter. Basically, we want this thing to wipe. Let's see. As this travels, we don't want it to go across something that's already been printed. We want it to stay on the geometry as much as possible because, remember, we have no retraction. We want the wisps and the crud to stay inside the print so that we don't see them. Hopefully makes it look a little nicer. So, all right. I think that should be good to go. We're doing 0.15. No, wait, what? Yes, 100%. Not 100 millimeters. I don't like that. I think you should have a drop down to select either percent or millimeters. All right, let's see what we got. This is going to be a very slow Benchy. Actually, it's not that bad. Yeah, it's 2 hours 45 minutes. So this super slow Benchy is about the same amount of time it would take to print full speed Benchy with a 0.4 millimeter nozzle. This is 0.6. It's pretty neat, huh? Anyways, let's send it off. And let's take a look. Well, let's send it away and see what we got here. All right. So we're let's see what's going on here. Oh, there we go. Yeah, no messing around with no more messing around with like trying to stream the camera, none of that crap. Nope, we're just going to run a really, really long USB cable directly into the 3D printer room, and we'll hook the printer up there. Unfortunately, due to some really weird interaction that I didn't know about, I can't hook up multiple cameras to it. So, or unless I can't run multiple cameras at the same time. So even though it's a USB 3.0 cable, it's a USB 3.0 hub, it's a USB 2.0 camera. And for some reason, if you connect a USB 2 device to USB 3 hub, it has like a dedicated 480 megabits per second. Basically, there isn't enough bandwidth. Even though there is enough bandwidth, it won't allocate, like the hub will not allocate enough of it to run multiple cameras. They fall back on USB 2.0 speeds. Unless I run a USB, unless I get some USB 3 cameras, which are expensive. All right, looks like our boat's done. We'll get to that in a sec. Let's get in here, though, and double check that the filament is going down and staying down. All right. Looks like it's sticking a little. Let's see. Looks like the sample bit, or like the priming line, stuck to our PEI. Maybe even a little too well. But it looks like the first layer is going down fairly well. It's coming out rough, but all the pictures, like all the demo pictures on the manufacturer's site looked rough. So I don't think that has anything to do with us. I'm going to raise it slightly. Let's see. Maybe I should be doing the opposite. I'm going to lower it. Yep. Yeah, so this, I don't think there's any way around it. I think we're just going to end up with a really scruffy looking Benchy. Seems like it's just the way the filament works. That's not good. It looks like we're getting some pretty bad under extrusion. And yeah, considering our extrusion multiplier is 1, I'm going to increase the idler tension. Because it might just not be gripping it hard enough to drive it through. Yeah, if it's because of the idler tension, then increasing our extrusion multiplier will have no effect. Because it doesn't matter how much we're trying to force through, if it's slipping... If the gear is slipping while trying to grab the filament, then it doesn't matter how fast we try to drive it. It's just not going to work. Okay, so I basically got this turned up to 100%. So let's see what happens. This is coming out very shaggy and scruffy. I suppose it's possible it took on water. But yeah, I suppose it's possible it took on water, but it could also be possible that it just looks like that, you know. All right, all right. Let's see what happened. In the meantime, let's turn our attention over here, and we want to get this off. Normally, you want to let the plate cool before you remove a print, but that's not how things work in high-temperature filament land. If we allow the plate to cool with the part still on it, it's going to crack. There's going to be too much tension. It's going to put too much tension on the plate, and it's going to break it. So here we go. It's good for my palette knife. So we want to get this thing off while it's still hot. Get them while they're hot. There we go. All right. So check this out here. So on the whole, this looks pretty good. You can see we have severe warping on the bottom. So yeah, we got real bad warping on the bottom. So could try using some fresh glue. But the layers are splitting apart. Yeah, check that out. Yeah, the layers are coming apart. So it looks like we're having the same. Looks like we had the same problems with this as we did with the peak. It's definitely not, like, the filament's definitely not waterlogged this time, because it's been dehydrating for around 4 days. Yeah, so check this out. It looks like it's more solid here at the base. See right here? It's pretty solid here at the base of the smokestack, and through the smokestack in general. So what I'm guessing here is that we were moving too fast and we were going too cold. So we're gonna crank. So we'll reprint this. And we'll crank up the heat. Yeah, check out this. Check out the splitting. We'll crank up the heat, and we'll turn down the print speed. And yeah, see if that does the job. Yeah, this is just the layers here are just peeling apart. Yeah, some real bad delamination going on here. Yeah, it's also possible, you know. It's also possible that our lack of we're being killed here by our lack of a heated chamber. Oh, I'm hearing clicking. We're jammed. Yeah, this filament's gonna be total hell. Yep. Hang on a sec. Tune. Change filament. Yeah, we gotta clear this. We gotta clear this jam. Yeah, hear that? Hear that clicking? Oh no! Well, now you can't. Yep, it's massive under extrusion. Yep, we have jammed the printer. So turning up the. Let's see. We're just going. You know what? I'm just gonna turn the printer off and turn it back on, because there is no way to restart. Let's see. I'm going to turn the printer off and back on, because there's no way to to cancel a print without finishing the filament filament sequence. Okay, so let's take a look here. Our printer did indeed reset. So this is what our bottom layer looks like. This stuff is not feeding very consistently. Even and then it jammed after I turned up the after I like clamped down on the filament. So how are we going to get out of this? We're basically on our own here because there wasn't very much online. Could be that we're leveled to. I mean, could be that we could baby step it down, but it just seems like there's not enough filament making its way through. Maybe it's too cold. You know, it says 210 everywhere, but could be that. Let's see. Could be it's too cold. Yeah, I mean it's always a possibility. It definitely seemed to stick to the Kapton. Yeah, it definitely seemed to stay put on the Kapton. All right. So let's see. First thing to do. All right. So today's a bit of a bust. I know my luck has not been very good lately. Yeah, my luck on these streams has not been very good lately. I think, yeah, so for Friday's stream, we're basically going to be doing the same, except, hopefully, assuming the right things go wrong, we're going to be getting Sanjay in from E3D. I think he's one of the I think the founders of E3D, and basically we're going to be talking about fancy filaments, and he'll be able to help us out. So that's going to be neat. It's not going to be me talking to myself. It's going to be me talking to Sanjay as we mess around with the printers. That's going to be really neat. As far as I know, he hasn't done a lot of interviews, so this is going to be fun. But yeah, I know that our record lately on finishing projects and streams hasn't been great, but for the next, let's see here. I'm just going to check my schedule. Yeah, for upcoming streams, I'm going to start. We're going to seed them with projects that are more sure shots. Because it's not fair that you folks watch stream after stream and nothing ever happens. I'm going to deliberately pick a topic that I know we are going to be able to do. So don't worry about that. Are we reconnected here? Excellent. So let's switch so let's bring this printer to 220 and get that filament out of there. So yeah, we're gonna be picking topics that are more sure shots, because it's no fun if nothing happens at stream after stream. In the meantime, it's been a while since I took a look at chat. Pardon me, folks. Let's take a look. Let's see who's hanging out here. Joel Driver says 0.6 millimeter nozzle. It already is. It's a 0.6 millimeter Olsen Ruby. Yeah, Skidface says looks like it absorbed water. That could be. We're already printing quite slow. Yeah, I'm going to. Yeah, we're already printing at 0.6. Yeah, we're going to try printing this at a higher temperature and see what happens. It could be that it's just too, it could be that, like, I trust him when he says when he says 210 Celsius. I trust him when he says it's going to be 210 Celsius, but it could be that the thermistor on the hot end is inaccurate. So, yeah. Yes, Darren Santos says, temp towers sound like a good idea for new filaments. Unfortunately, that doesn't fly if you're working on filament samples, because a temperature tower takes up about 100 grams of filament, depending on which one you print. Assuming it prints fine the first time. It uses somewhere around 75 to 100 grams of filament, and that's usually larger than the sample itself. So, yeah. S2 says, my Prusa is going to be here soon, just waiting on customs. Little Jewish maker birdie told me it's a great printer. I do like these printers a lot. This is pretty. What you're seeing here with the Prusa, like with the difficulty printing this filament, is it's pretty much the worst case scenario. This doesn't really. Yeah, this was the only filament that I've had real trouble on this machine with here. Wannabe Spaceman says, not going to lie, drying the filament is a process that costs no material and eliminates one cause. That is correct. Unfortunately, the filament dryer is currently tied up with high-temperature filaments. And if I were to try to dry this at the same temperature as the high-temp filaments, then it would melt. It would turn into a puddle. So I have to finish all of the... So unfortunately, I have to finish all the high-temperature filaments before I can dry anything else. Now, I had a food dehydrator. I had a food dehydrator in addition to the convection oven, but it stopped working, and I haven't had time to fix it. I was thinking of doing it today, but I think the odds are low. The odds are low that we'll actually successfully finish them. And you guys need a W, so we're only taking sure shots from now on. We're going to do one more try here. We're going to try elevating the temperature to 220. I'm going to do a complete purge. And, yeah, we're going to do a complete purge. We're going to run, I'm not going to run that purge filament through. We are going to run the nylon filament through to give it a complete flush, and then we're going to try again. And if that doesn't work, we have another filament that we can run here. We have other flexible filaments that I think we have some other flexible filaments. We have a neat engineering filament. We can also do a multi-material print, even though I really want to try those too. Where did I put the purge filament? Where did I put it? This workshop is so disorganized. Yeah, I also printed a big Voidstar Lab logo here. That print a big like Voidstar Lab logo that we can put on the that we can put on the door of the printer. So I think we'll probably add that on and add a little pizzazz to the proceedings. Wannabe Spaceman says, "Wait, is the gray stuff having print issues TPU?" I don't actually know what the material is. It's not the they don't provide any information about it. All I know is that it's chock full of retroreflective spheres. Apart from that, I have no idea what it's made of. Oh, yep, here's the empty spool that ran out last night. Man, I am not on a winning streak. That's okay. Projects fail. Statistically speaking, most projects fail. Alright, so let's wipe all the booger crud off of here. From Olsen Ruby, this needs a good brushing. Alright, so let's run. Alright, so let's run this filament through. Oh boy, that is a bad click. Looks like some of the filament broke off. Inside the nozzle. Alright, oh man, we're seeing. Is there a way I can get this on camera here? Let's see. I'm going to switch over to print our vision. And I'm going to try to point it up here. Unfortunately, I can't see the screen. Let's see, maybe if I drag it all the way up. All right. Let's see. There we go. It's kind of a dramatic angle, isn't it? Unexpectedly dramatic. Yeah, I don't like this mounting. Pardon the weird angle. This is on a bit of a strange mounting system that doesn't give me full freedom of motion. Trying to get this centered so you can't see the text. This stream is becoming a complete disaster, isn't it? Oh man, a stream where all I do is mess around with stuff, and it's still a total disaster. All right, so let's open this up and see what the damage is. I'm gonna move the the dehumidifier is filling up. I'm gonna have to drain this thing soon. All right, so let's open up the side hatch and see what the situation is. Oh, that is a giant filament blob. That is a giant filament blob. I wonder if when I thought it was. So we thought it was too. Here, let's grab some tweezers and try to yank that out. I thought it was too cold, but maybe it's too hot. Oh man, look at that. I guess you can't look at it because I'm blocking it. This giant glob of. Oh man, it's stuck. All right, I gotta grab some precision pliers. Yep, here we go. Let's try to get in there and yank it out without causing too much collateral damage. All right. It could also be that the Teflon tube, the PTFE. Oh, look at all that. Yeah, it got all tangled up. Could be the PTFE tube is damaged. Because I have been running a lot of filaments around 250 Celsius, which is about where PTFE starts to degrade. So it could be that the PTFE is no longer slick enough inside, or it could be that the lip of it deformed. Oh man, this is bad. There's filament wrapped up all over the place. Yeah, this is about the worst case scenario. I haven't had this happen on this printer since I upgraded it. Let's try to reverse while we grab. Okay. Yikes. Yikes on bikes. All right. So it looks like we've cleared out most of the crap. I'm going to screw the idler cover back on. I'm going to get the tip of my pinky hacked off by the hot end cooling fan. I really have to put a screen on that. The number of times I've whacked my finger in it is just far too high. And let's run a bunch of cleaning purge filament through this. Could be, yeah. I mean, could be that we have to dry this out. We'll give it one more shot though. It might turn out to be easier to print than we expected, because the problem we had was the trouble we ran into was fast. Like, it happened immediately, and probably something fundamental. I'm gonna run even more through it. Oh man, you can see all the little see all those little flecks there. Those are retroreflective particles being picked up by the cleaning filament. So this has a tremendous load of retroreflective particles, which that seems right. This guy likes when this guy puts additives. When Lay Filaments puts additives in a print or in a filament, they put a ton. Like, I think we used a wood from them. It was like a wood filament. It was like 40% wood. It's crazy. Okay, so we're gonna run this at 200. So we have this at 220. Let's try the exact opposite approach. I am going to release. I'm gonna release most of the tension on the extruder. Typically, what you want to do for that's usually the plan for a flexible filament. So let's see if that has any effect. So I'm actually gonna loosen it a lot. There we go. See how far in the screw is? Yeah, that's how you can tell. All right, so let's load in our flexible filament. I guess this is why you can't. I guess this is why it was so hard to find in a 1.75 millimeter size, because I'm guessing the 1.75 has a lot of trouble. 3 millimeter filament's less flexible as it goes in, which makes it easier to print. Yeah, see, nothing's happening. It's not driving. Makes it easier to print flexibles. Let's see. Oh man, I haven't had this much trouble printing flexible material since I did the upgrade on this. Oh, sorry about that. Yep, now it's jammed again. Let's unload it before it causes too much trouble. Nope, we're clogged again. Oh, this is bad. All right, all right. Hang on one sec. Let's think. Oh, it's such a disaster. Oh, gross. Oh, it's all wrapped up around the drive gear. Look, this is what happens. You print exotic filaments. There's a reason they're exotic. Now we have a piece of filament jamming up the works. Come on, get out of there. Yep, look at that. It's wrapped around the extruder. Never even made it. I don't even think it made it in. Maybe that's the issue. Maybe it's just not like making its way into the. Maybe it's just like not making its way into the throat of the PTFE tube. Here's what we're gonna do. We're gonna clip this at a really sharp angle, and I'm gonna feed it with the idler off. We're gonna feed it directly in. Here we go. Fed it directly into the hot end, and now. We're gonna close it back up again. Maintain a really low tension. and let's try printing a little of it. I'm not going to use the load button. Instead, we're going to go to move axis. I'm going to do it by hand. Just move it a small amount. I'm hearing some strange sounds. And we're seeing some filament come out. All right. Let's see. So it looks like filament's still coming. So it looks like it's oozing a lot, which does imply that the filament has water in it. But it does seem to be flowing. So, cool. All right. And we have this set at 220. So let's leave this where it is. And, all right. So let's leave this where it is. And I'm going to, hang on a sec. We have to angle this. I got to move this back out of the way, because otherwise when the gantry comes back down, it's going to whack into the camera. So let's just make sure that looks about all right. A little cockeyed, but whatever. Okay, so let's go back to configuring our filament. Let's see. All right. Okay. Right, we're gonna go back to. Sorry, it's like 80 something degrees in here. It's crazy hot. Let's go back to our slicer. Is this us? I think so. Okay, we're gonna go to print settings. We're gonna go back to speed, and I think we'll leave it where it is. I'm going to change the temperature to 215. Right? I think we're gonna do 215. I'm gonna leave the bed temperature. You know what? I'm gonna turn the bed temperature down to 40. Because it says we don't need. It says you don't need a heated bed, so I'm wondering if it's. If we're actually making things worse by making it easier for the filament to come off. Right. I'm also going to turn down the cooling. I don't think it's. I'm just going to turn it down to fixed 50%, because I think full might be a little too much. All right. We're going to disable the fan for the first 3 layers. And let's see, what else do we want to try here? Do we want to what do you think? Should we slow it down even further? Maybe we want to turn. Maybe we want to over extrude a little. I think that's what we want to do here. So let's go to filament settings. Let's over extrude by 5%, because the extruder drive is going to drive less filament through, because the diameter of the filament, remember, is going to change as it gets squished in the idler. So we're actually under extruding slightly. So let's up that. We're going to try 10% more and see what happens. Let's go to our print settings, and this is all very conservative. It's all very slow. So I'm going to change the infill to 15%. Or 15 millimeters per second. Everything is moving very slow. So let's give this a shot and see what happens. Reflectolay. Yeah. So let's see if this works any better. I mean, one thing to try. All right. Nate Williams says the build plate's printed a few boats. It has indeed. That was my old plate. So this, I mean, saying that I've done thousands of prints on it is probably a little disingenuous, because I've replaced the PEI itself wore out, so I've replaced it. Layer height. Randovan Obal asks, what's the layer height? Layer height is 0.15 millimeters on a 0.6 nozzle, which is about as low as we can go. Crow says, probably don't want retracts. You are correct. I have disabled retraction. Let's see. That rustling noise was us moving past the cleaning filament. There we go. I'm not hearing any popping, but we are seeing a little bit of oozing. But let's see what happens. The PTFE tube is definitely damaged. That's my next guess. If we still have trouble here, then we're going to have to strip the printer down and repair the PTFE tube. Because, yeah, it's definitely deformed, and, like, the part that's supposed to be flared is, like, all mangled, and, yeah, we put a lot of work through it, and we've printed a lot of high-temperature filaments that we probably shouldn't be printing with this printer. Because I only recently got the tool changer. And even then, it took a long time before it was set up and ready to roll. Okay, that line looks a lot better. Let's see how it continues. Let's see, number 2. I mean, it's looking rough, but I think that's, like, with such a high amount of such large particles, like, I can't believe this is going to extrude evenly. All right, so it looks like we're a little high. I'm going to bring it back down. I think we might. I'm a little like I'm inclined to say that we're under extruding still, but I don't know. I don't want to turn it up too high, because if this backs up, that's it. It's game over. Like, yeah, layers aren't exactly touching. This is, by the way, like, this is kind of the nature of the game with these filaments. That's actually looking alright. Let's leave that for now. Yeah, the gentleman who makes these things calls them experimental filaments, and that's really what they are. They are not with. There are a couple exceptions, but for the most part, these filaments are really hard to print. They are for people who, when I say experts, I mean like way above my level. But the results are really cool. There's another one that I want to print soon. I have to figure out how to spool it up, though. It's called Grolay, and it actually the idea is you wait. Dehumidifier's still running. I thought the dehumidifier stopped. Yeah, the idea is you soak it in water, and it creates this porous model that plants can grow in. It's really cool. So that layer is actually looking really good. It's nice to have a camera on the side. It lets me get in at an angle that that's usually too cramped to do. All right, so where do we go from here? We can try reprinting. I think we should try reprinting this. This is pretty nasty. This is a pretty nasty looking Benchy. All right, so here's what we'll do. I'm gonna go over to. Let's see. Yeah, I'm going over to our tool changer here. There is still plenty of adhesive on this bed. There is tons of it. So we are not going to add. I don't think we have to add more. Let's see. So I'm gonna we're gonna retry printing that Benchy on this. We're going to try reprinting the Benchy on the tool changer using our PEC filament, except I'm going to use the settings for for PSE. I'm going to use the settings we used before for PPS because they're slightly hotter, I guess. I'm not hearing any clicking. This actually seems to be printing fine. Let's bear with me one sec. I'm just going to go ahead and check on this, and then we'll do some more printing. We're building up a lot of crud on the nozzle. The nozzle's getting very dirty, which doesn't have me feeling very good. But it does seem like the filament is going down a-okay. So let's. It does look like the filament is going down, even though a lot of it is ending up on the nozzle instead. And I don't really know what to make of that. I guess we could. Yeah, I don't really know what to make of that. Let's see. It is the nozzle's a dirty boy. Alex asks, anyone here know how you got the Prusa bed leveling probe sequence to probe more than 9 points on the bed? It's a setting. It's just on the settings in the printer itself. It's I think maybe under calibration. It's called like mesh bed leveling, and you can say whether you want a 3.5, like 3x3, 5.5, or 7x7. And you can also tell it how many times it should probe, whether it should probe 3 times slowly or 5 times quickly. I haven't noticed any differences. I'm going to go into our I'm going to log into the Sultan of Squirt here, and I'm going to change our flow rate modifier to 100%. Yeah, yep, we're backed up. I'm hearing clicking. We blew it. Let's see if we can salvage this. Yeah, hear that? Yeah. Yeah, we're jammed. It's no good. Let's pop it open and see what the damage is. Yeah, this is going to be hard. This is giving me flashbacks from the it's giving me flashbacks from the 30 durometer filaments from the first episode. Yeah, that is a giant blob of filament. Yeah, it got wrapped around the extruder. Fortunately, we cannot remove the filament manually. So I'm going to just shut this off. Yeah, alright, that's a bust. I don't think this is something that we can do on stream. I think this is something that I have to do sitting right next to the printer. Carefully dialing parts in. Yeah, it did wrap around the gear again. Ryan Gill says, I've had good luck with the Nozzle X. We could try Nozzle X. I'm going to have to design custom profiles for it, though, because the Nozzle X... so the Nozzle X I have is in 0.4, 0.5, 0.6, and 0.8. And Prusa Slicer only has profiles for 0.25, 0.4, 0.6, and 0.8. And I think printing this at 0.8 is a little too aggressive. I think it's a little too much plastic, too much rope to be pushing at once. And the 0.4 millimeter nozzle, like I guess we could try running a 0.4 millimeter nozzle. I mean, what do you think? Could we just try? Maybe we should just try loading this into the other printer. The other printer has a newer it's a newer machine. It's got a newer PTFE tube, and it's fitted with a 0.4 millimeter Nozzle X. So I'm thinking we might have better luck running it on the lower printer. Unfortunately, I don't have a camera set up to that, and it would take too much time to transfer the camera. So, oh man. All right, let's take a break from this. Let's take a break from this. We don't want to. We don't want to get into that mindset where we become fixated on something and waste and start plunging time and resources back into it that it doesn't deserve. Stephen McLaughlin, thanks a lot for the 2 Canadian pesos. Did you make the cube chaser in the background? I sure did. It's called the Chromance. I did a video on it, and you can find it on today's sponsor, things.com, using the link in the description. I'm not actually sure I put it in things. Maybe I did. Yeah, it's called the Chromance. And I did a video on it. It's pretty cool. I made some pretty detailed instructions on building it too. Zoster, thank you so much for the super chat. I'm currently fighting with my printer too. We are all in this together. Indeed. Mike Philpott says, I just bought a Nozzle X and carbon fiber bed plate. Have you tried carbon fiber beds yet? They're stupid expensive. I could imagine. They must also be very hard to get perfectly flat. What does that give you? Is it like better heat transmission or more insulation or something? Yeah. Yeah, that sounds pretty interesting. All right, let's take a break from this. We don't want to get tunnel vision. So let's switch back over to the other printer, and yeah, let's try that again. So let's see. I'm opening up my print here. Let's see. So for the filament, we're going to turn it from 360 to 370. It's, you know what? Hang on a second. 360. Here's what we're going to do. I'm just going to log into the printer, and we're just going to rerun the previous job, which was in PPS. That prints at slightly higher temperatures, and I had that set to a slower speed. So I'm just going to open that up and redo that. See if those settings work well for the pack. Yeah. Let's see. Yeah, there we go here. Joel Driver says the issue is a low layer height. I disagree. I disagree because if we were to up the layer height, that means we'd be pushing more filament into the nozzle at once. And I think the problem is that we're trying to jam too much. We're trying to cram too much of a very soft filament into a PTFE tube that can't handle it. Yeah, it's a bit of a thing. Sean Collins asked, "What was the G code for the lights? How did I wire it?" So I can't show any of this because due to a really stupid confluence of events, I used all of my DC-DC buck regulator boards. And anyways, that uses one of those cheap DC-DC regulator boards. And the enable pin is tied to ground. It's hardwired to ground. So I sliced that loose, and I wired that to GPIO 76, which is the center pin of the row above the bed temperature sensor, I believe, on the Prusa. And then you can use M42, which is control GPIO pin, and then P76 to work on pin 76, followed by S0 to shut it off because the enable pin is active low. So yeah, Falcon says, "Do you have filament retractions on?" No, we do not. We disabled we disabled that. So no, I think this is just, you know what? I don't. It's a way of saying it. I don't think we're doing anything wrong here. Now that I'm thinking about it, we're not doing anything wrong. The filament we're trying to print is just, everything is against us here. It's extremely soft. It's crammed with, like, jam-packed with a very large particle. So I think in order to print this properly, we're gonna. Yeah, and it's probably a little dehydrated. It's probably got a little water in it. So in order to do this right, I think we're going to have to fully dehydrate it. And I'm going to strip the printer down, give the drive gears a full thorough cleaning, and cut a brand new PTFE tube and replace that. I suppose we could also try running it on a. We could also try running it on the tool changer, even though I haven't had great luck with flexible filaments. I think so. The drive gears, the drive gear and the idler were installed at the factory on these tool changer, on these Hemorrhoid tools on the tool changer. There, those ones, the ones right there, and one of them actually came loose. So I wonder if the trouble we're having with the tool changer is simply just sketchy installation, like just a drive gear that isn't fully screwed down. Like maybe I was supposed to take it apart and tighten it instead of just saying, "Oh, it's already together." Let's get in close and make sure everything's going down okay. It looks like it's all right. It's leveled a little. Let's see. It looks like it's leveled fine. We'll see if there's enough adhesive. There might not be. Because I did lay this down without any adhesive. Yeah, you know what? We're gonna cancel this and we're gonna add more nano adhesive. Why am I so stingy with it? You may ask. Because it's $50 a bottle. Let's cancel that print. Get that out of there. It drops the bed way too much. I'm so paranoid about snapping the heater block off one of the tools. So it's dropping the bed way too far. All right, so let's get this out of here. Oh, let's get this out of here. Let's get our brush. Let's get our nanopolymer adhesive. I don't even know what a nanopolymer would be. Like, what's nano about it? It's a liquid. Like, it's a clear liquid, so there's not even anything suspended in it. Did they just put nano on it because they thought it sounded cool? Who does that? All right. Once more with feeling. Print again. All right. Don't have to worry about letting it dry because, like, it's in the minute or so it's going to take to relevel and everything. It's going to be okay. Yeah, let's see. We've got a few. All right. So let's think. Let's think here. How do we want to proceed? Do we want to try again? I don't think so. Maybe we should. You know what? Like, here's an idea. Let's just try running a different flexible filament, right? Like, if we run a different flex filament, and that one also fails in a similar way, it also starts wrapping around, then we'll know that it's probably a physical problem with the extruder. So I think that's the way to go. I think that's the way to go. So let's switch back over to our print our vision, and let's see. I gotta get the lights. Oh wow, there's a. The bed is a lot more tilted than it was last time. That's interesting. Let me take a look at that height map. Yeah, it's the bed's listing to one side. I wonder if the clips are starting to loosen up, or if we damage the Here, take a look. Yeah, the bed is listing to one side. It wasn't this bad before. So if this fails again, we'll have to take this down for maintenance too. Crap, I've got to get more stuff done. Falling behind on all our deadlines here. This is terrible. Anyways, yeah, let's switch back to this. I'm going to log into the Sultan of Squirt, and first off, we're going to reconnect to it. I can't control it. Can't control it if we're not connected to it. So let's go into our terminal and let's. Are we gonna? Oh, we're not gonna connect. Awesome. Awesome. Now we're going to have to diagnose serial issues. I think we may end up ending this stream early. It's pretty clear that there's very little is going to come from the rest of this stream. This is one disaster after another. I did turn it back on. No, I didn't. That would explain why it's not connecting. Because I didn't turn it back on. All right. While I'm here, let's scrape this off. Let's remove this Kapton. Yeah, like the first few layers went down great, and then it just, alas, just wasn't fated to be. All right, there we go. There we go. It's a lot easier to connect to a printer when it's on. All right, let's take a look back here. Oh, that looks much better. That looks much better. Okay, we're moving slower. We're printing hotter. I think between the two of those, that should get this PEC working. Cool, cool, cool. There's a little bit of a booger going on there. Let's grab that and yank it off. There we go. All right. So first things first, let's get in there and let's yank out that the remnant of the reflectolay. There we go. Oh man, it's curled all the way down through the back. Oh, look at that. Oh, it's awful. All right, let's close this back up. All right. So we'll bring this up to 215. I'm going to take this filament and put it back on the wall. So we're going to bring it up to 215. We're going to purge it, and then we'll run a different flexible material. So let's see. What are our options? I think the spiciest one, the spiciest filament that we can run here, the spiciest flex is this. Hang on a sec. Where is it? Here we go. It is going to be this. This is Ninja Tech Eel electrically conductive flexible filament, which I think we'd be able to use to make some pretty interesting wearable devices. But yeah, I think we should give that a shot. It's also a very soft filament. Yeah, also very soft filament. Feels neighborhood of 30 durometer. So if this works, but the others don't, then the other doesn't, then we know it's We know it's probably the filament. If this also fails in the same way, then we can safely assume that it's the printer that's acting up. This hanger, by the way, is also... I also printed these, although we're not going to be using it right now. So let's remove the hanger. Let's mount the filament right here. All right, let's get ourselves some cleaning filament in there. Let's get that crap out of there. Get those reflective, show those reflective particles the door. Get that retro reflective ass out of here. Let's see. Can you see what's going on over there? I can't see it. Gotta figure out some way to keep an eye on the stream when I'm running around. Need a handheld camera or something, or I don't know. We need to give Brooke like a switchboard, so she can like switch between camera angles and whatnot. Just make like a whole broadcast studio. All right. So let's unload this. All right. And let's head back over here and quickly look up how to print with what's it called? Ninja Flex Eel filament. This one is 90A. That seems, I guess it could be 90A. All right, it's ESD. It's conductive, ESD dissipating. TPU. Look at that. $145 a kilo. We have a small sample of it. Truly flexible conductive material. Fashion. Yeah, there you go. LED gloves, wearable devices. Yeah, we can make some pretty sick stuff with this. It ends up working. We already have some glue. All right, so we want to print medium speed. All right, 220 to 230. So, yeah. All right, so it looks like there's nothing really special going on here. 15 to 20 millimeters. I'm just thinking here. Let's back here. Wait, hang on a second. I meant, yeah, here we go. Let's go back to our print settings here. You know what? For comparison's sake, we're going to use the exact same settings. All we're going to do is adjust the temperature, because this says it wanted to be printed at 225, and let's make the bed 50 Celsius. Let's call it 45. It doesn't have. It said the room temperature to be a certain temperature. I don't know. Let's take a look at what it said about cooling as well. Layer 2, use cooling fan if available. So let's give it the juice. All right, disable fan for the first layer. All right, so I think this is about what we want. Let's head back in here and just load up our eel. I think it's supposed to be like an electric eel. I think the Ninja Flex likes to name their stuff after animals. I don't know why they didn't name it after ninja stuff. It kind of seems obvious, right? So let's see how well this works. If this also eats poop the same way, then we know it's the printer. But if this works fine, then we can be pretty confident in saying that it's the filament. Or rather, like, our settings and configuration. I wish I had a battery for my multimeter so I could tell you exactly how conductive this is. All right, very nice. Ow. So let's switch back over. Let's take a look here, and I'm going to slice it and send it. Eel. There we go. Cool, cool, cool. There we go. Dingle Dodger says, are there any non-flexible conductive filaments, preferably affordable? Certainly on the first, certainly not on the second. Yeah. There are a ton of flexible filament. There are a ton of not flex. There are a ton of rigid non-conductive filaments. In the last episode, or in the last every filament episode, I used who made it? Who made it? Who made it? I forget. Anyways, I used some ESD PLA. Oh, it was Protopasta. Right. I used Protopasta PLA. Used Protopasta conductive PLA. That was pretty sick. And for this, we've got conductive PETG, and I think we also got some more. Yeah, we got some more conductive PLA. That's more ESD safe. I think we have some ESD safe ABS as well. Yeah, they're all expensive though, because the way you make filament conductive is with graphene, basically like carbon nano thingies. Polgovsky says, clean that bed. OMG. No. If I cleaned the bed, I wouldn't have glue on the bed, and then the filament would stick to it permanently and I'd never be able to get it off. Wheels FPV says, your printer's dragging something. I don't think it'll be a problem. I don't think it'll be a problem. We can go in and I can go in and remove it. We can ask it nicely. There we go. Get that out of there. So let's take a gander here. What's going on? It's printing so slow. All right. Definitely want to lower it a little. It's printing a bit too high. Actually, I think it was fine before. Yeah, I think it was fine. I think I overcompensated. Not the first time in my life, huh? All right. It seems to be going down fine, but let's keep an eye on it. And more importantly, let's keep an ear out for it. I'm going to leave the door open so that we can hear any clicking sounds. So we've got both printers going. Very nice. And unfortunately, they're both going very, very slowly, so there's no chance for going to be able to film. Eric Anderson says, do flex filaments bond to PEI and destroy it? They won't necessarily destroy it, but they have a high chance of destroying it. Yeah, they can permanently. Flexible filaments can bond really strongly to anything. They're one of those filaments that like either they don't stick or they permanently stick. So without glue stick, they can be really hard to get off of almost anything. PEI is especially bad because they can get stuck on there pretty friggin' hard. Yeah, they get pretty nuts. Man, I wish I could manually focus this camera so close. Silly. Arcades, I think, says you have disabled fan only for first layer. I know it says use the fan the second layer. That means I have to turn it off in the first layer. Yeah. Andrew K says, can you ground things to a chassis of conductive PETG? It's an interesting question. I think it would be better than nothing, but it wouldn't. Yeah, because it's a low. I don't know. I would say if your goal is to reduce ESD, like if your goal is to prevent ESD from making its way inside, then yeah, that would be perfect. But if your goal is to prevent any problems caused by high voltage AC, like walls, like mains from the wall, then no, it is too high impedance. You want metal, like pure metal. Yeah, Xneem says you can easily pull a bubble on the PI sticker with flexibles. Yeah, it's true. They can grab onto it and yank it off. There has to be, like, how does that work though? Because like, there's no air they can make it in, right? Like, is it just a vacuum in a bubble? Weird. Let's see. Oh, did I miss a super chat? Oh, never mind. That was a few minutes ago. Yeah. Emmerich Knack says, what's your favorite pie variation? Well, I know there are certain products called things like the banana pie, but those are not pies. They have appropriated the name, and the Raspberry Pi Foundation hasn't sued them for some reason. My absolute favorite Raspberry Pi of them all is the Pi 4, like the newest one. Hang on, what's the newest one? Is the Pi 4 the one with the one with the USB-C? Oh man, am I blanking? The newest Raspberry Pi, I think, is that gets to the point where it has enough power to do exactly what you want it to do without lagging. Like, it's got enough oomph that it can run a website. It can play some basic games, run a good interface, even do some real-time computer vision and stuff, and does it really nice and fast. And it's got memory, it's got all kinds of stuff. Basically, that is the first Raspberry Pi that I would honestly be okay with using as a daily driver computer. I think it's powerful enough to actually get stuff done. Pi 4, yeah, I think it's great. The Pi 4 compute module should be a shoo-in. That should be a clear winner. But there just haven't been that many people making. Sorry about that. There's haven't been that many people like integrating them into products. Like there's the Pi Nora, which is all right. There are a few. There's a new Stereo Pi coming out. The Stereo Pi is a great product. But yeah, the compute module should be it, but there just aren't enough modules for it. The RPi 400 is pretty neat. It's very expensive for what you get. The RPi 400 is neat. It's not how I generally use a Pi. Like, most of my Pis are pretty much, for all intents and purposes, all of my Pis are just controlling something else. Like, they're all headless, except for this one here, whose job it is to display a UI. So none of them have keyboards on them. So it's yeah, like, and that was cool. It's a cool product. If you're going to use a Pi for a computer, it's definitely the right choice. It also made a kick-ass cyber deck. Let me tell you, that made a great cyber deck. But I just don't have as much use for them. Yeah, they're a really cool product. They have a great heatsink on them. They also use like the golden they use like golden chips in it, so they actually perform better than your average Pi 4. They're pretty sick. Mm. Let's see. MW Free says, that's a huge printhead. How's it working without the linear rails? It's not. The camera is just really close to it. It's not big. It's just really close. Isn't that the joke? Like I'm not fat. I'm just really close. That's how it works. So this looks like it's still working all right. Let's go in for a closer look. Let's be vigilant here. Let's see. Is it still being pulled in? I can't tell. Because the layer surface is pretty rough. So let's see. The question is it being pulled in? Nope. No, we are jammed. It's not making any noise, but nope, we are 100% jammed. All right, so I think it's safe to say it's the printer. Yeah, I think it's safe to say it's a printer. It looks all right in camera, but it's no good. Crap. All right. Well, that makes sort of two printers down for work. Sultan, cancel it. Yes, and let's move the head up and out of the way. Oh well. Yeah, I think in running all these filaments, like, this printer's been running nonstop for days, running all kinds of random stuff. I'm guessing that the PTFE tube inside has just worn out, or there's crud built up on the gears. I'm guessing the printer itself needs some maintenance. The nozzle probably also needs a cold. I guess I can't cold pull it because it's a ruby. Yeah, you can't cold pull a ruby. It'll rip the gem right out of the end of it. So yeah, I think that thing needs to be stripped down. I guess we could do that here. I think it's there's too much going on right now, though. I think we just need to take this printer out of commission and switch over to one of the other ones, or just try running just try running a non-flexible filament in it. Ollie K says the transport wheel worn. It could be, yeah, it could be. Yeah. Let me think here. Christopher Garcia says, when you research for your videos, can you elaborate on the type of research you do and where you get your materials? I no longer do videos that I have to research for. We just don't have time. The circuit, yeah, like the wire circuits on boards video took like a week to research, and like that's fine, right? Because like what's the difference between like a week of printing and a week of a week of printing or a week of project building or a week of research. But no, we can't do any projects. We can't do anything anymore that requires both a project and research. There just isn't time for it. So currently, I only do things that I'm fairly confident I know off the top of my head, and the research mostly involves going back to the resources that I used to learn it in the first place and just confirming that I'm not misremembering anything. Red Knight says, incomplete Benchy spotted. What are we, Oh, it came loose, peeled off. All right, so that's a bust too. Unfortunately, today is a total wash. We haven't gotten anything accomplished today. Yeah. Oh man, fuck. Oh, that sucks. I feel terrible, folks. I'm trying really hard to. Yikes! This is real dangerous. Because on one hand, it's a very ungratifying stream if nothing comes out of it. Yeah, it's not a very fun stream if I keep running these things and keep being failure after failure. And this also puts me in a really dangerous situation regarding keeping my commitments to finish my videos on time. Yikes on bikes. My butthole is 100% clenched right now. What happened? Let's see. This curled extremely aggressively. And it looks like the layers, yeah, it looks like the layers delaminated. Hear that? Yeah, the layers aren't sticking. So I've already, let's see. It could be that the filament is, could be the filament took on water in the time it took to wind it up. So the filament could be waterlogged. It's very, yeah. Yeah, it didn't just curl, it like completely came apart. I think we blew it. I think the filament took on too much water. So we're gonna have to throw that back in the dehydrator. And damn, oh man, I'm in a terrible situation right now. Anyways, you don't come to YouTube for pessimism. You come to YouTube to be inspired and to be distracted from your own pessimism. So I think I need to end the stream then. Yeah. Yeah, thanks to Things for sponsoring this episode. Make sure you, wow, I am so friggin' flustered. My heart is beating like 150 beats per minute. Hang on a second. All right, thanks to Things for sponsoring this episode. Assuming your printing will take. Your printing will work a lot better than mine because I assume you're not using exotic filaments like polyether ketone, and flexible filament crammed with retroreflective particles. So, if you'd like to prove that to yourself, make sure you use the link in the description, go to things.com, and check out all the cool prints there. I gotta share the prints. Oh man, have I got a to-do list? I gotta share the prints for the accessories I did for E3D Tool Changer. Make sure, though, you show up on Friday because we're bringing in a special guest. We're getting Sanjay from E3D to talk about fancy materials and all kinds of good stuff like that. Yeah, talk about fancy materials, talk about what it's like being in the business, how to make stuff that everyone can print with. Yeah, make sure you use the link in the description that shows them that we sent you, supports the channel, etc., etc. I swear on my life, this will be we've had failures in the last 3 streams. The next stream we're not really going to be working on a project. We're just going to be printing stuff while we chat. The following one, though, I'm scratching what we were going to do. It's a guaranteed victory. Show up and let's finish a project. Yeah, it's not fair to have you. It's not fair to show failure after failure to you guys, and I will not. So this is it. The losing streak has ended. Make sure you tune in on Friday to listen to this exclusive interview. Make sure you check in next Monday. I have something that I'm sure we're going to be able to get done. It's going to be cool as heck. And yeah. What else? Yeah, thanks to all the patrons whose names have been scrolling back there. Thanks to everyone who supported the channel with a little super chat action. I really appreciate it. Yeah, next video is going to be seriously delayed because everything is going to hell. But yeah, it's going to be a nice one. We're going to be showing off all of our 3D printing equipment. So I've never really done anything like that before. I've never shown off our gear. I'm always very quiet about what... I don't know. I talk a lot. I try to talk about the projects, and I try to avoid focusing on the tools, because I know it can become bragging very easily. But I've decided that we're gonna set that aside to for the next video, because it's about time I show you all the 3D printing stuff. I always kind of show it at a distance. Anyways, yeah, make sure you're subscribed to get that. Thanks a lot to Thanks for sponsoring. Thanks to you for watching. It's been a real experience, which I don't intend to repeat, and I will see each and every one of you in the future. Take care, and have a great week.